Okay, so yesterday's main theme was really file system design, file system layout, the mechanics of building a file system, understanding how the RAID LUNs are being built, understanding the stripe width and segment size of that LUN, and then being able to trace it back through XVM and understand stripe units, stripe width, and how to build stripes, concats, and mirrors, and combinations of them. So in lab, one of the things you do is you take a device and slice it 8 ways, and then build a 4-way stripe, and then grow the file system, attach the other 4 stripes, or the other 4 slices have been striped, and create a complex concat stripe. And some of the reasons for doing that sort of thing. Again, I do feel that some sites tend to over-stripe. And this goes back to how many concurrent I/O operations are going on in a particular file system. And if I've got a lot of storage for capacity, I don't necessarily just want to stripe that capacity across everything, but to build concat objects that are reasonably striped, but to build the capacity with the concats, and each concat is basically decoupled or segregated in its I/O stream from the others. Again, when you're striping, especially when you're writing, the drives act like a single drive. When I've got concat objects, there is some decoupling and independence of them. So if I pound on one concat stripe group, there's not going to be contention created across all the other drives and RAIDs that are within that file system. And this goes back to the main thing that I was trying to say from the beginning of the week. On these big systems especially, I don't want to spread everything across everything. It's kind of like going from a 2-lane freeway to a 12-lane freeway. Yes, during non-rush hour, you don't have the bottlenecks. But when the utilization of the road goes up and every space of the road is covered with a car and everybody's trying to change lanes and do context switching and stuff, the contention gets worse the more lanes you have. This is something that I need to talk about today. There are 3 things I want to talk about today but get into tomorrow, and that's due to CPU sets, and that is 3 things in a CPU set: mem hard wall, spread page cache, or memory spread page and memory spread slab. And these things are right now set up to spread everything across everything, which made sense on the Itanium systems, number 1, because memory was attached to the hub, not to the socket. Also, memory was smaller in those machines. One of the main reasons they did the spread was that an application would read a file in, it would fill up all the memory in the node, then the application would start allocating memory and throw everything it read away. So by putting a mem hard wall, which, by the way, changed defaults from SLES 10 to SLES 11. In SLES 10, everything was a mem hard wall. You could not break outside of your CPU set. With 11, they created the mem hard wall setting, but flipped its default from a hard wall to no hard wall, which means I can now slop memory outside of my CPU set, creating contention across the whole machine. So the hot button for me really is mem hard wall first, so that an application, if it decides that it wants to spread things, spreads them across the nodes that are in the CPU set, and hopefully the batch system is giving them contiguous CPU sets that are within the same IRU. I cannot endorse a user CPU set, for example, that has 1 blade per IRU, because all that's now going through the interconnect a lot more deeper and stuff. I'd like to keep things within the same blade or the same IRU, even down to the same socket. So I need to come back to the 3 CPU set settings that need to be looked at more closely. And I tried to get a set UID type of program that would allow a job to actually set those settings appropriate for their type of application. So you could actually default to setting mem hard wall to a 1 and setting the spreads to a 0. And then if an application cannot hold its assets on a node and we're thrashing off node, then you flip them. This whole thing goes back to my Ferrari School Bus 747 story. Does my payload fit? If I can hold my assets and not be busting the socket's memory, that's what I want. I want affinity, I want locality. That's going to be your best thing. If I can't hold it local, then I'm going to be looking at interleaves and round-robin techniques. But that's going to be a lot less common for a default, I believe, than Itanium systems. Because number one, you've got a lot more memory on a per node basis, so you don't need to spread it if you can hold it local. If it stays on socket, why spread it around? And the other key thing here was that we know going across the interconnect is going to have an impact and increased latency. And thirdly, our memory is now tightly coupled to the socket, not tightly coupled to the hub like it was in our prior NumaLink systems. So file system I/O, even if I do CPU sets, I am still spreading everything across the whole system. This includes network sockets. This includes NFS caches. Take a look. Sometime do a more on proc slab info. And you'll see all the structures that by default are spread round robin. So the last site was actually trying to create user CPU sets that were affinity aware to where the network interface was coming in for their NFS. But then the spread memory slab was round robining across all 128 nodes, creating a lot of contention and dependency. If I'm trying to go across the interconnect and somebody else is pounding on the interconnect, I have a higher probability of contention when everything is going across everything. So people always ask me, how do I tune a UV? And I basically say, number one, you want to lock things down, privatize them. Don't be bouncing around between CPUs, and keep everything you can on socket, even better on core. Lock things down so that I'm not bouncing around. In other words, turn off the CPU scheduler. Give me affinity to just one CPU, and only dplays can do that. And also try to make sure that everything that thread on that CPU needs is on socket, except there may be global variables or something like that that they may have to go across the interconnect to get to. We okay with that concept?
Sure.
Yep.
So the slab is spread round robin across all nodes, and 128 nodes and spreading it across, there is going to be some impact on NFS and everything else. So this site was trying to get affinity, but didn't realize that all the slab was being spread across all the nodes, and all the page cache is spread across all the nodes. Also, Jeff, your issue when you were running the Calic program and watching go from one node to the other. My first comment on that was we want to actually make the initialization multi-threaded, and Calic can't really do that. I don't know if you ever did get a chance to multi-thread it. But the other thing is when I'm referencing the data later, even though I may swap from one node to the next, I got to make sure the thread that is using the data has the data on node. And this is where a lot of sites are taking algorithms and making sure that the initialization of the data space is affinity thread aware. And it's one thing that NumaCTL cannot do is say this threads and this address range placed on this node. That was something we could do in IRIX. dplays did have memory placement capability, and dprof could actually generate a dplays file that would say this thread uses this address range, place them on this particular node, so that everything is locked down and privatized. So Jeff, try that same experiment with interleave, NumaCTL-I interleave. You will find that it's slower than the other way. But I'm not so much concerned about the initialization of the array and the clearing of it. I'm more concerned about the post-processing of it. So it may take me longer to initialize the array as long as when I start processing the array, it's affinity thread local socket placed.
Right.
But go ahead and try playing with multi-threading a dash parallel with ICC, and try the NumaCTL-I interleave. But again, all that thing really does is initialize the array. It does not post-process it. Okay, so that's the most important thing that's unique about UV. It is a little bit more sensitive, in my opinion, to affinity than the prior NumaLink systems. Again, primarily because the memory is now on the socket. And that's your hot path. You just want to lock things down on the processor socket and the memory that's attached to it. Okay, so yesterday we talked about file system layout, and I need to go back and demo it, but as usual, I like to start off the morning with some sort of experiment, so I'm going to go off and take a look at Floyd 2 as a group and try real hard not to hang it before I try to clean up the mess. So I am just going to start off with health of the system, SAR 1 space 5. I'm not going to use PCP right now, and it does not look too healthy to me. 50% system time. Now, when I'm looking at this data, my first question is that a good number, is that a bad number, and how does that fit into the big picture? You can have good system time, you can have bad system time. Doing I/O requires system time. There's some things that require system time. System time, again, is a kernel spin lock, and the whole intention of a spin lock in the kernel is to prevent multiple CPUs from changing a structure in the kernel at the same time, to protect the integrity of that table. The more CPUs have, the higher potential of creating system time and contention on given locks. So I can have good system time, I can have bad system time. I can have good interactive response, but high system time, and right now, my interactive response is quite healthy compared to yesterday. And I can have low system time and bad interactive performance. I need to know what that system time is. So how do I figure out what that system time is? I do have that cheat sheet there. So I assume SAR with system time. How do I narrow down, how do I drill down into my system time?
If you have TopSys, you can run that.
That's a good start. Any other tools?
I mean, I'm cheating because I already looked, but Top was quite useful too.
Yes, but you're not getting the main tool that I want. How do I find out what my system time is? And if you're watching my desktop, I'm having a little bit of a trouble here. I'm going to log out and log back in.
I'm not sure if your VNC is going to work. I was just checking the log files, and it looks like there's some sort of a device file that, or one of the devices is full, and VNC
full of what?
write.
That's why I wanted you to look ahead of things. What's full?
I haven't been able to figure that out yet.
Aha. Yeah, I'm not seeing a full device. My root file system does have 85% used, but it's still got 10 gig available.
But if you look at var log messages, you won't see, or you'll see error messages at the end of var log messages.
Here, for example, is one.
Yeah. So I think that's what's killing your access with VNC.
Yeah. Thank you. Good. So we need to figure out more because df-h isn't showing me anything. So let me go back. No, that's fine. But you're not getting the key command I was interested in. SAR 1 space 5 shows me I still got high system time. In fact, I'm just going to do a SAR. Oops. Got a problem here. Darn. Wonder why. No var log SA23. No
try df. That isn't the command you're looking for.
What's that?
df-I shows the problem. That's the command.
So you've jumped ahead, that's fine. But that wasn't the command I was asking for earlier. I'm asking about what the percent system time is. How can I profile it? So I'm going to do a top sys as you suggested. I tried to go baseline to figure out what's going on here, but there isn't any data for today, and I know that this is all related to the same problem that Jeff just spotted. And this is why I try to run this thing overnight, because it takes a while to hit this limit. Now, everything that I'm trying to do in this class, and I tried to warn you about this, Jeff, I'm pushing bottlenecks. I'm not running one copy. I'm deliberately trying to run multiple concurrent copies and drive the bottleneck up. I want to see how the system behaves on the high end of the bottleneck before I hit my limits. So when we were talking about calc and stuff like that, I was trying to point out concurrent issues, not just single-threaded. Okay? So let me just back up here, SAR 1 space 5. Again, I always like to go back to see if I'm in the same state, and I am. Top sys was where I was going to go next, and this will tell me what processes are causing the system time. And I see kjournald. What does that make you think?
The kernel journal daemon is struggling to write something.
Well, what journal though?
That would be ext3.
Correct. And I believe ext4 still calls it the same. I don't think there's any real...
yeah, sorry. I was more in the ext versus XFS.
Correct. And I'm just trying to say there is an ext4 kernel module that gets loaded, but I'm not seeing anything unique at the daemon level when that's loaded.
Okay.
But I've not found any good documentation on ext4 yet, other than the generic marketing type of stuff. So, again, my PID, my user ID, D stands for delta, so this is in the kernel 100% of the time, 100% system time. And then the amount of time in time instead of percentage, and then this is since process started. Since the process started. Then the CPU they're on, then the amount of time they have. Okay? Now I'm going to do a ps-e. Look at, I even have some SAR commands. SA1 is what's collecting my 10-minute samples, and those are stuck, defunct. In fact, I got a lot of them.
And you can see that it's the same loop of send mail and
send mail.
Right.
Now, when I see this, and I'm not saying this is the problem right now, but it makes me think buffer cache buffers. Look how cron is stuck. They're all stuck.
Yeah.
Again, I just did a ps-e on a 2048 CPU system. That's going to be 30,000 threads before you actually get to your work. Don't know of any way easily of cleaning that out. When you do a ps-p with a PID list, that is much quicker and more efficient. When I specify PIDs, it's a lot quicker and does skip over those 30,000. But I wasn't able to do a ps-p on a thread ID, only the parent process ID. Okay, so here are those code 5s again, and we've already looked at code 5. It's postmark, and it's basically creating a metadata storm, directories, and inodes. And again, I deliberately have a lot of them running. And then right there is where we start with our other problems. There is an option to actually see when they actually started, right? So it looks like some of these cron daemons actually started yesterday. So let's see, this is midnight, 50, 40, 30, 20, 10. There's 11 o'clock right there. Looks like it started about 11 o'clock last night. Okay? ps-e and grep for code 5. So I'm going to do an strace. and dash big T will give me the elapsed time or wall clock time of the system call I'm tracing, and two little t's will give me a timestamp. And then my thread ID, let me just pick one, 14783. Oh, this one's in a remove, RMDIR. In fact, let me do the df-I that Jeff is talking about. We are still at a 0 here. Let me do a watch df-I. And I do have stuff going on in Scratch. (9065-0807). It looks like the free 3014. 4207. So it looks like the Scratch file system. The RMs look like they're going on in the Scratch file system. And this is what Jeff spotted earlier. I was just hoping temp would be separated out so that I could actually log in and get X going and stuff. Okay. PS-E pipe grep code. Let me go back to an earlier one here. I picked one at the end of the list, which meant it started later. Let me try an strace dash capital T, two little t's, dash P 13442. And this one is one of them that's experiencing the problem. No space left on the device, so it's trying to do a make dir. Okay, and it's failing. So with strace, I would do a man2, and then the name of the system call, 2 indicating give me a system call, and ouch, I can't even get that because it can't create a temp directory because it can't create an inode. So it would have told me this is the file and this is the permissions. And after the equal sign is the return status on the system call, and that varies depending upon the system call. Now this is a case where they have reused the same system call, and no space left on device is kind of a generic one that we even used to get in a CPU set situation when we try to use a CPU that wasn't really there. So it's only showing start at yesterday at June 22nd for everything. Everything started on June 22nd. Okay. Let me go back to what I was doing. SAR1-5, I'm just making sure I'm still in the same situation. It's the 60% system time that I'm interested in, or that system time in general. I do have some IO8 going on. I'm not going to concern myself with that right now. PS-EL and grep for, let's just try sync. And sync buffer, and the kernel kjournal D is one of them that is showing up periodically to cause that IO wait time. The other one was a GET request. That's an XFS journal daemon. See if I can catch it. And the other one was congestion. I'm not seeing that one right now. So that's what looks like mostly metadata, and the journaling activity looks to be what the IO8 is from. That there. Okay, I'm going to do a SAR-R1-5. I'm just kind of going through the health of the system. And my memory is all full. And my reservations, half my memory has been reserved. Now, the thing I don't like about SAR-R is it doesn't give me detail. It's too coarse of an information. Oh darn, I thought I had a bigger K-bus. So I've got about 159 meg of buffers. I'm hoping that the PCP logs are going to be intact, because the PM logger had started and was able to create the files before this event started. But I won't know yet. Let's see here, 54 out of my 131, about half my memory is in cache. But again, I always found it strange here. Nothing here tells me how much memory is for applications, how big is the kernel, those sorts of things. Let me do a SAR-DP 1-5. I'll come back to memory. So I'm looking at CPU, memory, and then disk. And it is wrapping, but I see both SDA and SDB being busy. SDB has a lot of I/O operations, a lot of reads going on. Now the average wait time and the average service time is a little high there, but my root isn't too bad. And that's a good reason to explain why my interactive response is fairly reasonable. The other day when we had a root problem, we had much higher wait times on it. But it is still 70% busy. So when I see numbers that are fairly healthy like this, but busy like this, I look for head movement first. Unfortunately, I don't have SeqWatcher here to actually see that. Celeste 11 SP2, I'd be able to bring up SeqWatcher and see what kind of head movement I have. So SeqWatcher is taking block trace data and profiling each I/O operation on a per device basis. And then I could find out what kind of head movement's going on there. Okay, again, just doing SAR from beginning doesn't help me to get a baseline, so I really don't know where the baseline normally is right now. I'm going to bring up top disk. And again, I don't have a complicated file system here. I only got 2 drives and 2 partitions. So SDA does have some minor writes going on, and SDB is still 13, 17K, that sort of thing. And there are some reads going on there as well. Now, right now, I do not want to go into SDB and do any fragmentation statistics or anything like that. Okay. So, other than the drive being busy, things look fairly healthy. I'm going to do a SAR-B 1-5, and this is basically just totaling, for both of you, this is coming out of the block SCSI layer. It is the same data that is in the SAR-DP. It's just been added as a total for all devices. So this is the exact same data, exact same values coming out of here, just totaled up together. So that's the sum of what's going on at the block SCSI layer for all devices. It is a total of proc disk stats. And this is also coming out of proc disk stats. So again, right now I can see I'm writing more than reading. Most of my transactions are right, and I've got a lot of blocks written. I'm going to try a SAR-R 1-5. Doesn't look like anything's happening with my buff mem, the raw I/O buffers. And again, this is just kind of bouncing around. I really don't have a large enough interval to see what's going on here, but I'm seeing grow, shrink, grow, shrink, grow, shrink. When it's going positive, minus, these page resources are bouncing around. They're going up and down, up and down, up and down. Okay, so I've looked at CPU. System time was a concern to me. A little bit of IO8. I looked at memory, but I didn't get enough detail of memory. By the way, I forgot SAR-capital S 1-5. Oh, and my swaps used up too. I'm out of swap. What about out-of-memory killer? Am I in an out-of-memory killer situation? Any comments, Jeff? Would I be an out-of-memory killer yet? So CPU, memory, disk. I really need to look at file system buffer cache. All my memory's gone, all my swap's gone. The question is, can I trim what's in memory?
Right.
And that's what I can't get out of SAR. You okay with me, Thomas? So I was going through CPU memory disk. Now I'm saying, okay, I got to look at file system buffer cache. If I have stuff that's reclaimable, then I'm not in an out-of-memory killer situation. By the way, I want to check something here, cat.sysctl.com. And I had switched swappiness to 100 overnight to try to protect the cache and cause applications to swap. That's a good reason why I may have stuff out on the swap device. If I've dropped it down to 0, then I might not have swapping going on. And again, I don't know what's out on the swap device yet. I'm going to come back to these later today with the page cache documentation. Those 5 buttons right there. But again, just think swappiness, how swappy will a process be? The higher the number, the more likely the process will get swapped. The lower the number, the more likely we will trim the cache. So I am protecting my cache and protecting my cache assets. Maybe they're important to me. On a laptop, bringing up web browsers and stuff like that, the swappiness by default is 60, which is protecting my cache and giving you some swappiness of suspended or unused windows and stuff like that that may be going on in iconized browser windows and stuff. So it kind of makes sense to have it at 60 for the laptop market, but not in the HPC market. The other one I had here, VFS cache pressure. This is again protecting the cache over the protecting the slab over the cache, as I remember. Let me double check that again. Decreasing causes the kernel to prefer and protect the slab. So I've done everything here to protect the slab. And then I also said the slab can use all of memory. The other thing that I did here was saying half my memory can get dirty before I start flushing it. Okay, now I'm going to come back to that. So let me go back to SAR-S1-5. So we do have swap used, but I don't know an accurate enough picture of what's going on in memory. So I am just going to go to procmem info here. So I got 189 meg of memory free. I got 160 meg of raw I/O, which I'm pretty sure is the journal. I got 54 meg of cached. Now, what's one of the key things to look for in cached? No dirty, no write back. Ouch, right there. Shemem. 50 of that 54 gig is Shemem. I'm kind of balanced here between active and inactive, but it looks like most of my memory is in user space, non-pages. And then I've got about 4 gig of cache that's split between active and inactive. Its swappiness is what's controlling this. If I have a high swappiness, that means I'm going to have a lot of active. When you have a high swappiness, this is going to be high. We're going to have most of our stuff being kept active and very little non-inactive. No, I'm sorry. I did it the other way around. I back up. Swappiness of 100 is going to cause the application to be swappy. So if I have a swappiness of 100, I should have much higher inactive than active. If I drop swappiness down to 0, that's going to protect the application, making it a lot of active and making the cache inactive. Hopefully I didn't confuse you too bad. We'll come back to that later. So again, with a swappiness high, I'm going to have a high file active. With a swappiness low, I'm going to have a high anon active. When I trim, when I run out of memory, instead of swapping, I'm going to trim the inactive first. So if I have a high swappiness, I'm going to end up trimming the inactive anon first, and then the inactive file. I'm sorry, I should actually say I'm going to trim the inactive file and then the inactive anon. I'm going to do files before anon. And we need to cover that later today, the trim process. So I'm tripping up on my tongue here, but hopefully I'm not getting you too confused. Very little mapped. Where was anon pages? Very little anon pages. Now this is interesting to me. My anon pages are real small here, but real big here. And again, that's because shemem is in this area. Now what else is big in memory? What's the biggest thing in memory?
The cache pages.
I'm not hearing the answer I like.
Yeah,
what's the biggest thing in memory?
Slab.
Thank you. A lot easier when, let me, where was I here? Oops. A lot easier when I can visualize the memory map. And Thomas, that's why I tried to get you to build this memory map earlier in the week. So I got two yellows here. Let me just click on one. The lower one is the slab. It looks like I have almost a 75 gig slab or something like that. The other thing on top of that is cache clean, and then the other thing on top of that is my shemem. If I click on shemem down here, again, shemem is being counted twice, so what's in yellow and what's in brown are the same assets. But they do not appear to be attached to anything because nothing is showing up as anon pages or mapped. Neither of those are big. Okay, so just looking at my total system activity, which we were doing manually, I can see my system time going up and down. Actually, let me get the samples wider. I like to see more data. I can see the correlations better. So my CPU is not healthy. I got high system time. Now I asked earlier, no one gave me an answer, but how can I find out what that system time is? We don't know yet. What's the command that hangs me?
Oh, perf top.
Perf top is what I was asking for, Jeff. But at the same time, it's risky because it will hang the system. I don't want to run it yet. Okay, memory does not look healthy at all. The question that I'm going to do here is time. I can do two things. You can decide what we do. Do we figure out how long it takes to reboot the system and handle all the metadata that's there? Or do we see how long it takes to trim it? Think about that. Figure out which you want to do. Do I push it down with memhog and time that? Or do I time a reboot in at 6? And I can see my drives are pretty busy and not healthy either. But again, my file systems here, we're just showing file system disk space capacity, not inodes.
But PCP can show you the inodes, right?
Yes, in different ways. Not a df-i capability. I don't know of any way that it does that. There's no probe for PCP that gets DF-I data.
Huh,
There is
okay.
SAR-V to tell me how much, and that's available through PCP. Again, Thomas, I'm not sure if you're familiar with this, PMinfo-T. Let's just grep for inodes. There we are. It does have it. I'm correcting myself now. Let's go back to PCP and add that. File,
free.
new chart. Well, I use PMinfo quite a bit, but I didn't think I had what Jeff was asking about, but in fact it is there in file sys. Let's see, what was that?
It's free files and used files.
Used files, I think. Now, again, you're not going to typically hit this bottleneck, but I do it on purpose. And that's not in percentage. So it's not going to be obvious from that,
Wouldn't you be better off
Jeff.
watching free files to see if it's above 0?
I didn't understand that, Thomas. What was that?
So there's free files and used files. So wouldn't you be better off watching?
Here, let's take a look at that one.
Just because you don't, if you're looking at used files, I don't think is it a percentage?
Yeah.
Oh, it is a
No, it
percentage.
isn't. That's what you got.
Okay. Actually, I was just thinking if it was just a number of files, then you wouldn't necessarily know if you were full or empty.
Let's see what we got there. So neither are in percentage. And the problem now with the free files one is the ones that are 0 are, there's one here that's red that's way up on top. It's going to be hard to spot if it weren't in percentage or something. So I got rid of the red. But again, it's buried in noise. You really can't see it down here.
Okay.
Let me try to get to a bigger screen here. So we got some up here in free files, and then there's some way down here in noise. So it'd be kind of hard. Let me try changing. I'm just seeing if I can find a better way to look at this and go to a stack bar, for example. And then I can get rid of the red and get rid of the green. And I see I've got one, the blue SDA1 that's at 0. But again, when it's at 0, it's so buried in noise, you're not going to spot it. So these are all good ideas.
Yeah, Dave, so often I'll just do a PM-val minus S1,
yeah.
whatever metric it is, because then I get a quick view, and yeah, then the fact that you've got this big number smearing your ability to see something else.
So Jeff is just pointing out the command line way of getting ASCII out of the probe instead of the graphic. Let's see, free files. And this is again a case where the graphic tool doesn't really help because things are buried in noise. Just like node info, there are times where an ASCII tool is going to be better. And now it's more visible to us. And I'm not going to worry about the fat. So that's a good point. Anything else right now? So we're talking about meminfo. And the key thing here that we were seeing was most of my slab is reclaimable. So that means I'm not going to hit the out-of-memory killer. I would push all this stuff down. There is still a possibility of hitting out-of-memory killer for other reasons.
Okay.
And again, we are not in a CPU set scenario yet either that could result in ohms going on the system. So, one of the things I wanted to point out then, in my own toolkit, I just basically have a SAR type of report, and it's an awk script that's easily modified that would give me a SAR style report to actually look at my procmem info in a line type of fashion, making it a little bit easier to spot the slab. I wish that SAR would actually have this stuff available in the binary activity file and be able to print out a more detailed memory report. I just got annoyed with the guy because he took things off the line that were important and put stuff that is irrelevant. The commit and the commit ratio are irrelevant since we can overcommit by default. I much preferred other things there. So we went CPU, memory, disk, file system, buffer, cache, IPC. So right now we're seeing Inode high system time. We're seeing inodes reaching 0, no space left on device from various things, and then df-i showing that we got no inode space. We also see a large cache and a large slab, and we've seen that the cache field is mostly shemem. I did not put shemem in this particular display yet, but it would be easy to do. It's a real simple script to write. I don't have any dirty and write-back. That's where we're going today with the dirty write-back stuff. Not showing any map, but again, I have a large slab. So how do I look at the slab? How do I find out what those assets are?
Good cat proc slab info.
Yeah.
But that's, I mean, I find that really hard to read because I'm not that.
So this is telling me the structures that are in the slab. I was talking about this earlier, dev CPU set. Let me cat it. Cat / dev / CPU set / memory spread slab. That's a 1 globally. So all these slab structures are spread across all nodes on the system. Now, if I'm on a 2-node or 4-node system, I don't mind that so much, but if I'm on a 256-node system, I'm not sure I want to spread everything across everything. So here's some of my NFS area. Remote procedure calls, part of NFS. I don't care about IPv6 yet. I think let me back up. XFS information, look at this right here. See there's some big numbers there. More XFS information. XPMEM for cross-partition stuff, DM, extended 3, inode cache, handles for the journal, SCSI information, disk quotas. I'm looking for the sockets and stuff. I'm not sure what an MRT cache is, but that's network related. TCP bind bucket, a pure cache, ARP cache. That looks like a socket pool. More inode for sockets. Shemem inode, normal inode. Oh, look at this one. Here's my directory entries.
And what if you go up a little bit, there's this radix.
That's NFS. This one here.
Okay, the radix under tree under node.
Yeah. So when I'm doing LSs on NFS mounted file systems, it shows up there.
Got it.
I was looking, I saw the sockets, but I was looking for network buffers and stuff too. And again, this would be like a 4 meg memory pool. I was talking about the one site that everything was this size. They had 9 gig of that, which I assume was the page cache for GPFS. Now, I'm fine with what you suggested, Jeff. There's my process table. okay? So my process table is going to be spread everything. Now, I don't have a way of finding out, I don't know of a way of finding out what nodes, how that table is spread across things. I don't know, I just know that the slab itself is allocated round robin across all nodes. But I don't know how to find out which nodes this particular structure is on, for example. So that GPFS scenario, they were trying to get affinity to NFS and GPFS, but then not realizing that everything is, they're losing affinity as soon as it's read in by these structures. But now, this isn't exactly what I was looking for, Jeff, so what's the tool to process this?
You could run slab top.
That's what I was looking for. Oh, by the way, I have been told that they don't want me. There is a little bit of documentation in the workbook on the tunables that are in slabs. So there is a tunable area with a limit, a batch count, and a shared factor. But they don't want really that addressed, only if in particular, Jack Steiner says tweak it. And it's been about 5 years since that has been used as a workaround. Most of these don't really have a limit. They're dynamic, except for the size of the limited size of the slab itself. So I do not cover any, those are not commonly tweaked. So slab top dash S space C. And by the way, again, with this 50% system time, my interactive response has been pretty tolerable. Any ideas yet on what that system time is? No space left on device.
Yeah.
So S space C, I wish that was the default. The default is to sort by this one, but that doesn't give you a memory footprint. So I always try to sort by S space C to get the cache size, and here I can see XFS is top of the slab. Well, that's interesting because root is the one that's full, and root is an extended 3.
Right.
Then I got directory entries, more XFS, this is NFS, and something that was 64 bytes in size. Here's my extended 3 inode cache. Not a whole lot there, really. And my NFS inode cache. Now, Jeff, I know that radix tree node, it has to do with NFS, but I've never gone into the NFS code to figure out details on it. Okay, I'm just going to do a kill all on go.bottle.64 if they're there, and kill all code. Oh, before I do that, fuser-uvm on /scratch because we saw stuff there. And there are a whole bunch of code files that are running there. And that was, I believe, an XFS file system. SDB, SDA.
It's the bottom, Dave.
There we are. That's right, because it was a XVM. So that's proving this in XFS. And we did have an external log, but it's on the same device, so we're really not going to be able to measure that much. Let me go back to PCP here for a minute. Add tab, SCR. New chart, disk by partition. Let's just look at IOPS, number of reads, writes for SDB. Yeah, we can't even, because it's XVM, we can't even break it out. Let's see what this does. And then the writes. Remember, XVM is a block device. It has an elevator, but not everything, the elevators are not exactly the same as the elevators for a true block device. They don't do everything like read-aheads and stuff. something that I got information from Jeremy Higdon on, but I've not added into the manual yet. And it doesn't look like I'm getting anything out of that particular counter. So it's just not counting. That SCSI layer shows up, but there's no statistics being collected for it is what I'm expecting, which is why you usually don't see it in SAR or TOP. Okay. So the other thing, fuser -uvm on slash, and let's just grep for code again. And I do have some things, I got more than code. Probably wrote it to standard error instead of standard out. Is that what happened? I don't know. Yeah, I don't like when they do that. S-trace, I don't like. Things that I want to post-process or filter, I prefer to go to standard out, not standard error. fuser-uvm on slash. So I can see all those crons, but I'm not able, and there's some of the code files that are running as well. I'm also going to do an LSOF and grep for code, pipe it into more. So now I can see the directories they're running in, so some are in temp. And I should have some running in Scratch as well, once I get past my main ones. Sometimes I might grep by PID. There we are, now we're into the Scratch file system. So I fired off this thing in the root file system first, and then the Scratch file system. In fact, the Scratch file system, they were removing things. Directory removes going on. I don't have any directory creates anymore. So in the XFS file system, the go.bottle script is in the cleaning up phase, not the creation phase at this point. We're going to talk about this in this next slide coming up, or lecture portion coming up. Again, I got a bug with how I get out of it. And if I break out of it wrong, it continues refreshing, running in the background. Okay. What am I missing now? So we know what the slab is. It was mostly XFS data. By the way, SAR-V, don't have anything there. SAR-V, 1-5. And I wish I could see it from midnight or whatever. But directories and inodes, and again, grep slab/proc/mem-info. And I've got a almost 77 gig kernel right now. But what else was missing? We skipped over one other resource. IPCS-AM. We had a large cache as well. There was 50 gig of cache. 10, 20, I've got 30 gig there. What else should I check? That's only 30 gig if I grep shmem and /proc/mem-info. That's 50 gig there. We're missing some shmem. What else could it be? First of all, IPCS only shows yourself unless you're root. But I also have a file in dev shmem which does not show up with IPCS. And that stuff is not going to be recoverable. If I do a BC free, that's not going to do anything. Okay? Any questions right now? Okay, so now I'm wondering whether I should try a perf top and get out real quickly, or reboot the system and time it, or run memhog and see how long it takes to get memory back and trim the slab, or I could even do a BC free and see what happens. Does anybody have any particular direction they'd like to go from here? I would like to keep the shemem there at this point and not clean that up yet. I'd like to see the impact of whatever I try to do is on the slab, whether it's a reboot, a trim from memhog, or a trim from BC free.
Do the BC free to trim the slab.
On just the slab?
Yeah.
Let me go first and do it just on the cache.
Okay.
So a lot of people get bit by this. They say, oh, I've got a large cache. Let me go to memory. Let me get rid of shemem. I'm just leaving shemem in there to keep the pressure there and to suck up memory for the time being. But here they're sitting there saying, okay, I've got 50 gig of cache. Okay, and they say, well, gee, now do you want me to use BC free or drop caches? So sysctl-8 for Thomas's sake. BC free simply calls drop caches. But it does check to make sure you're root, and if you're not root, it uses memhog to do the trim instead of using drop caches. So let me just do a BC free -A to start with, okay?
As long as you have a C after the B.
Thank you. I even have my reading glasses on.
And
we are getting some trim. Now, it's going to be hard to see, but some of the things that just got trimmed include share text and the shell and stuff. Usually, right after a BC free, you can see the disk activity, read it all back in. Now, because we got high writes, let me get back here and go down to disk activity. Look at what happened during, we dropped data. But there were definitely some disk reads that went on in there, and we still have disk reads happening. Reading stuff back in.
Lo and behold, you're the same size.
I'm sorry, I didn't understand.
Look at your cache size. Is it any smaller? No.
No. We did get a trim. So there was about 4 gig, it looks like, roughly. That did get trimmed. Okay, well, what I was also trying to say is DSOs and shared memory and stuff like that are going to have to get read back in right afterwards. I'm not sure that this is all from that, but it looks like I should have been watching at the time, but I'm assuming my BC free started right there, and then as we were doing a BC free, stuff that was active was reading stuff back into memory again. And now we've kind of settled down, not back to where we were before, but I'm going to put that whole read bump there due to the BC free trimming stuff that was actively being used. But I can't prove that. If I had no I/O and did this sort of thing, then it's easy to see it. And we can see the I/O weight associated with it too. And notice my slab did not get trimmed yet. Let me get the slab back in. Okay, so now the next question was, let me just double check here, SAR-R1-5. We don't really have a very big buffers. In fact, the buffers did get trimmed in that too. The buffers got trimmed down at the same time. Let's see if we can catch that here. Get rid of the slab, get rid of cache. Yeah, you can see where the buffers got trimmed in. They're growing back up again. Jeff, that's the journal. That's what's going on there.
Sure.
Extended 3 journal, not XFS. XFS is a fixed raw memory space for the journaling. Extended 3 and extended 4 as well does the same thing. It can use all the memory for the journaling activity. Any questions? So now the question is whether I want to do a BC free. I don't think I can even do a man yet. Still can't do it. The code 5s are still running, creating the intensity at the same time. BC free-H. So there is an F option to say trim the slab only. So I'm back to the question, do we want to take a reboot and time that? Because we have a large slab and it's going to take time to make sure everything is coherent on the shutdown? Or do we do a BC free-F or a memhog to try to trim the slab? Those are our three choices right now, and I'm going to take a break here. So
I'm for a time BC free-F because, yes, you can reboot, but if you're looking for a minimum impact, in theory, you would run a command, and the fact, and
sure.
We're getting a time for how long does this take, you may be able to tell customers, nah, yeah, you may think this is what you want to do, but it's going to take just as long.
And tomorrow we can try the other one. But this is what burned me, and by the way, now this is a big thing to note here for both of you. As of a year ago, XFS now tracks directory access times, and when this first hit me, the locate script running find sucked up all my memory. It did not used to do that. Find or an ls-r did not used to cause a metadata change. Now it does. So all I had was a locate script, and then I came in the morning, tried to do a reboot, and it took me 3 hours to reboot the system.
So, isn't there an option to find to tell it not to affect?
Correct. But the default behavior changed. So if a site isn't aware enough about this and they try to do a shutdown and wonder, oh, it's taking a long time, and then they manually reset because they gave up thinking that it hung because it did not have this behavior before. So that's the only reason I was suggesting the init 6. But no, I'm fine with we can do an init 6 tomorrow, and right now let me just do a BC free or a memhog. Which would you like? I think memhog would be more realistic.
Because a user may try to do it versus having root do it?
An application is more likely. The question is, rather than using drop caches where the kernel cleans house, let's just run an application that's going to need the memory and force the trim.
Okay.
You okay with what we're talking about, Thomas?
Yep.
So it was like 2 years ago or something like that I got bit and was trying to shut down my system. And I am deliberately running my inode counts as right up to the limit just to demonstrate this effect. And twice after I've done this at a site, they actually had this scenario happen at their site where they had a inode storm, shall we say, metadata storm happening. So I'm deliberately doing this and seeing how it behaves on the upper end of the bottleneck. So I'm going to suggest we basically...
But is this because the inodes are cached in memory, and is that a problem because we have so much memory, or...
I have deliberately tuned it to allow all my memory to go to the slab, but there's a difference between whether they're cached or being modified. So in this case, I have a hot journal because kjournald is showing up, and that tells me that the metadata isn't just being cached, it's being modified, brought into memory, modified, and then it's got to flush out.
Okay.
And the file system can't keep up with the metadata storm that's going on. And right now we can see the fact that my journal is growing here from extended 3.
So, but is this something that's going to be more of a problem with more memory? It's more of a noticeable issue?
Yes. definitely.
Okay.
And keep in mind, one of the reasons I'm talking about this is when I run into a trim, when I ask for memory, it's the slab that's going to get pushed down first. I've already trimmed the cache with the BC free. I had one case where if I'd done a BC free before I asked for memory, the BC free trimmed the cache, and then the application got its memory fine. In fact, it was tar. But another case, I did not run BC free, so it trimmed the slab first, and the slab was huge, and it took a day to trim the slab at that time.
Okay.
But I also want to reinforce, if I try to shut down and it seems like it hung on a shutdown, if I don't know that my slab got this big and I do a reset, I now have an inconsistent file system.
Okay. And so the reason it would take so long to trim slab, would it be correct to say that that's because it's got to then take all those dirty pages and write them to disk?
Well, at the time, it was a poor slab trim algorithm, too.
Okay.
But that's why I'm saying, if I run out of
memory,
memory, I'm going to have to push the slab down first, and particularly if the slab has a find or an LS going on, and it's a large slab, and the more CPUs you have, the higher the intensity of the metadata storm, I may not be able to push it down quick enough. And then I'm stuck trying to trim the slab, when in fact I could have trimmed the cache first and gotten the memory I needed to run.
okay.
Now again, I have changed min-slab ratio to 99 and modified swappiness and VFS cache pressure to exaggerate this effect.
Okay. But when we trim slab, does it have to wait on disk I/O?
Yes, disks will get busy. It has to make everything coherent.
Okay. That's just what I was trying to figure out. So that would be why why trimming slab is so expensive then?
And it goes back to the algorithms that are doing the slab trims. And again, SGI having these large memory machines, the default right now is 5% of your memory for the slab. So 5% of 16 gig is, or 16 terabytes is still like 4 terabytes.
Yeah.
And I'm not even, I'm at 70 gig or something like that. So just taking a 70 gig kernel slab and seeing how long it trims from a memhog, with the possibility of the largest being like 4 terabyte.
So is that something that we would typically tune when we send something out of the factory, or is that something we wait until it's an issue?
Wait till it's an issue.
Okay.
Now, the SGI base configuration does try to do some default settings in sysctl.conf, but they are not right, and it's too politically hot a subject. I do have an RFE to be able to address these on larger memory machines.
Okay.
And when we come back, we need to talk about buffer cache and the dirty ratio too. But yeah, being the fact that we're into much larger memory machines, the intensity and larger CPU counts, the intensity of the problems get much more severe.
You should also point out a couple more things. One,
go ahead.
SGI base config, for the most part, although it doesn't say UV in the name, is UV specific. If you look at the script, the second or third line is this a UV? If it is, keep going. If it's not, bail right now. So I kind of object to the name.
I don't, Jeff, there should be things that are going on XEs and stuff. It is x86 Performance Suite specific, they renamed it. But that's the same package that should be loading Systat on other platforms too.
Right.
So I know there's UV specific stuff in there, but it should still have some of the other stuff for non-UV.
Yeah, the other thing I want to point out is that for the most part, manufacturing loads the current version of
Performance
the
Suite
software and does absolutely nothing else.
Yeah.
There are exceptions to that where engineering says we need you to pick up this patch or this kernel or whatever, but customers have noticed that they get if they get a new SLUS 11 SP1 system that's not a UV, for example, that all of the RPMs are old because they're the base SLUS 11 SP1 RPMs, and they wonder why. Well, because updates are the responsibility of the customer. And this has a little tension, partially because the customers don't understand that we cannot agree for them to the contractual relationship that they end up having with Novell. So because we can't agree for them, we can't apply updates.
Okay.
And in general, they don't know how to get the updates or whether they're entitled or not. That's what Troy was complaining about.
Troy McCorkle or?
No, at Oak Ridge.
Oh,
Troy Bauer?
Yeah. Well, that's partially because you're putting a SLES machine in the midst of a huge Red Hat installation. And,
agreed, and he didn't read any documentation because he said he got none, let alone the start here. Yeah. Anyway, anything else you want to throw in?
You know, my personal view is if you can get the installers of the machine, the humans, on the machine before it leaves the factory to give them some idea, this is what you got, this is how it is, da-da-da-da-da-da. Then when it gets there, they can deal with, they know what they have and where it might want to go. For the most part, this only happens when there's PS involved.
Yeah.
I think that's a fundamental flaw. I've not yet been able to convince enough people that it is a fundamental flaw and we ought to do something about it, but.
And Thomas, my main point at the beginning of the week was the more I understand my workload characteristics, the more responsible these configuration decisions are.
Yeah, I guess just one of my concerns is we do sell like a service with it to implement Linux typically, but that's typically going to be more for like setting up IP addresses, setting up host names, so mounting file systems. You know,
our website says professional services offers tuning services too.
Yeah, so I think that.
I never found out who that was.
Okay, so one of the things here, right, is too, at what point, you know, often, you know, someone will sell several days of installation services and it's kind of generic as to what it is, or there's actual statement of work and there's real PS involvement because there's a statement of work. Who ends up doing what becomes very ill-defined. For example, SEs, because they often know better what the customer's workload is and they know the applications versus the field service staff, oftentimes end up doing some of the installation services which are make the applications run that the field service simply doesn't know how to do. So you end up doing post-sales stuff that isn't really in your job description, making customers happy.
And I'd rather have that than a site tank on a system and go to a different platform.
Oh, yeah. I mean, it's just that
it's a fuzzy.
Thomas's point here is that it's a little ill-defined as to who does what, and because it's ill-defined, sometimes things are missed that could have been done ahead. You could have bound the LUNs while it was sitting in the factory. You know, you could have set up users or quotas.
Yeah. I mean, and like you said, it is fairly ill-defined. I'm more just trying to figure out, like, how much of this stuff is things that we should be tweaking right off the bat, like, that I should change right off the bat when a system arrives. Like, you know, do we want to, you know, make sure the slab doesn't grow to, say, 80 gigs? Or, you know, what kind of things do we really need to watch out for at that point? Because I don't think that those are necessarily, you know, front of anyone's mind.
No, you just wait till the problem's there. Problem is, the problem will sit there for a year or two.
Yeah.
And that's what I don't like. And then they blame it on SGI versus implementation. Let me fire off this memhog.
Okay.
And we take a break. At least let me fire off the memhog here. Oops. So let's see what gets trimmed first. So there's my application. We've now hit out of memory. You can see memhog is actually stalled out now. Let me get rid of the slab. Let me get rid of the cache. And how's your interactive response right now?
It's okay, I just did a tail minus F.
Okay.
I mean, I can type.
My PCP is stalling out on me.
Yeah,
I was looking to see if BuffMan was going to get trimmed first.
Yeah, and the tail is not responsive. I mean, I typed it in, and hit enter, but.
And I'm basically dropping data now.
Yeah.
And my
so
memhog 10 gig is stalled out.
Yeah, so this is my objection to memhog.
What?
That it now forces the system into a behavior
trim.
mode where if you use BC free to drop the slab with drop caches, I mean that's what it's going to do, right? BC free on if you ask it to do slab does what? If you ask BC free
might
to
be more efficient.
Or will it make the system have this behavior?
No matter what, you're trimming used assets.
Yeah, yeah.
So you're still creating a pressure on a memory footprint that has to shrink.
Oh, certainly, yeah. So BC free, if you did capital F, what does it actually do? Is it still using the sysctl for drop caches?
Yes.
Sets it to 2?
Unless you're not root, then it runs memhog.
Right. But so it sets it to 2, right?
What, BC free? If I do the -F, yes, it sets it to 2.
Okay.
And only if I'm not root does it use memhog.
Right.
So I started this at 10:37. You want to take a break now?
Yes, please.
So let's come back at like 5 minutes to the hour, 15-minute break. That work for everyone?
Sure.
And, oh, that's right, I can't record here. I was going to record my PCP data if it snaps back, but this is one of the reasons I don't like to see I don't want things to get out of control and things like the slab to get too big. And remember also, I have shemem in here that's unattached. That stuff would get squeezed out the swap. The swap's already full, probably from the shemem. I didn't want to clean up the shemem yet. I wanted to try to trim and see how the trim happens. But let's take a 15-minute break here, okay?
Okay.
the reason, I mean, John Hesselberg, when I was designed, you know, there was a big push against having compilers installed by default because, well, there's space, but you're also not supposed to be compiling, you know, compiling on C blades, putting load on the NSF server. That's the purpose of the login installation. So that was the reason for it. I mean, we complained about it initially, but learned about it. So, but if they're there, that's great. You know, I do something similar, right? No. Well, it's got to be the same thing running on it. But it just seems like a synchronization problem. But if you're looking at the you use NFS synchronization, you mean? These are all shared files. I mean, it should be but it seems easier some way to compile one. It's all the paradigm you have, right? If you're, you know, on the other hand, a cluster is supposed to be easy to use as a single system. And if you submit a job to a single system, you can build and run, you know. And in fact, building might be part of the work that you're doing. It could be. Could be. So, that's good to hear. I didn't know that. So, yeah, so hopefully he keeps that on his addendum and future configurations. Just add it to the yeah. And we could have, it would help us just test more. Do you have performance tests from last week? That's not a synthesis. Do you have a performance test suite? We have a set of benchmarks. You mean something self-checking? Yes. Does anyone? Well, does anyone? The thing about self-checking is, yes, you have to self-check with a table that says, okay, what processor, how many, is it cluster, what's internet, what's speed? Yes. Right, so that would be, given our experience just maintaining the correctness of functionality of a correctness test base, imagine compounding the maintenance burden of that with maintaining an accurate table of performance results. Yeah, you don't get that. But what we do have are there are some things about our environment that
Are we back yet?
Yep.
Yep.
So, during break, a memhog did come back after 8 minutes but it didn't trim the slab. I now have a partially wedged system. Is anybody logged in to Floyd 2 and able to get any sort of response? I logged into the operator console, and I am able to get a response there. I'm not coming in through networks and stuff. Remember, networks have to get stuff out of the slab. I don't know what's going on right now. I'm just thinking aloud.
So the tail -F I started on varlog messages never finished. No, sorry, never started. So my SSH session is wedged there.
Yeah. Anybody got responsiveness? I've only got this one window, it appears. I fired off an SSH to it, and it couldn't get anything. Keep in mind, I still have these, let's see if they're still running, and see what they're in. All log weights, XFS log for XFS, and then log weights for extended 3.
Right, so one SSH session that has nothing running is still responsive to keyboard to return.
So some of them do appear to be having some lock contention issues, particularly the master thread that when I come in is going to have to fork things off. So my PM chart is dead. The only thing I've got is this one window. But it's responsive, but it's not dependent upon networks, and network buffers are in the slab, and we're trying to put pressure on the slab. That's just my thought right now, okay? So let's take a look at what we can figure out here. SAR1-5, no utilization, system time is a lot lower than it was before. Still IO 8, SAR-R1-5. I'm still at 99% of my memory being used. I still have a 50 gig cache. I'm going to free that up here coming up. And my buffers about the same where they were before. Again, I do seem to have gotten a couple of SAR samples today. Remember, I did an RM to try to free up inodes?
Right.
But it just happened to sneak one in there. PS-EL and grep for RM. I do still have that RM running. strace-t on 23981. So it is still running and doing unlinks. But I got all those code 5s that are basically taking up the slots as they're running. Now I'm going to kill off some things, clean things up, and see if I can get my system back without actually having to reset right now. Again, maybe at the end of the day, if I'm still in this scenario and have decided to let it happen, I might try it in at 6 to see what can happen. So what do you think I'd want to do here, Jeff?
Me personally, I'd start killing code 5 like mad.
Well,
this has an application
that
I no longer care about.
That doesn't help me diagnose and prevent this scenario from happening again. I don't disagree with that, but before I do that, again, let me cat/proc/mem-info. So my slab is actually not trimming.
Right.
Now, how can I see, all these things are stuck. How can I see what they're stuck on?
You could go to KDB.
That's what I was looking for. Before I start interacting, as you suggested, I would drop to KDB, grab an Arch KDB output, and then try to recover. That's my personal opinion. Now we're down to 102, 108 meg of memory free. Swap free is 0. We could be in an out of memory killer situation right now. But again, we should be trying to trim the cache. That slab, try to trim the slab. That slab should get trimmed. Now, before I start killing code 5s, what's another idea? Let me break out of here for a second. I'm going to pipe into TEE, hang 2. Usually I'll put a date on it or something like that, some sort of description on the snapshot I'm going to get. So Thomas, you remember how to get KDB output?
Yeah, I think so.
Go ahead, tell me what to do.
So is the escape KDB?
Correct, uppercase KDB. And I'm in KDB. Now, when I hit that perf top, I could not drop into KDB because interrupts were being masked, including the non-maskable interrupt was being masked. So when I hit that perf top hang, even a power NMI would not drop me to KDB. I have had cases for both of you where it took 5 minutes for me to get into KDB on a large CPU count and stuff. So you'll usually know that the keystrokes did get picked up and that KDB is working, but you may still have to wait for it to respond to things. There is a help capability, and when we were in an situation at Oak Ridge, I taught them how to basically kill a process. I wish I had a kill all on these code 503s if I had a choice. Okay, so I'm just going to do an arch KDB, and it's going to give me the summary report first, which is procmem info. Then it's going to give me a PS and a D message. With D message, I'd be able to spot if I'm in an out-of-memory killer situation right now. Then it will give me a backtrace. So there's the PS. There's the D message. And there's the backtrace. So Jeff, I've had a lot of classes in Germany and stuff like that, and these administrators say it's wedged, so they just reset. And my opinion is, I've got a behavioral problem here. Let's snapshot what's going on. Now, there is a slight risk of this being catastrophic. But at Oak Ridge, the administrator didn't realize escape KDB is how you get to it. He was using NMI, which is catastrophic. Look at this bash shell. Here's where we are. Here's us trying to do things interactive. Shrink slab. I only had a 70 gig slab here. And unfortunately, the min slab ratio, I think the smallest it can go is 5, but even 1% of a 16 terabyte machine is still a lot of memory for the slab to be. Also, at the beginning of the week, it looked like I had left slab ratio alone. It looked like my slab still grew to the whole machine. I'm going to try that tonight and get slab ratio back down to 5, which is the current default. So this machine is all wedged on shrink slab. Okay? I'm going to type in go. I do have response here. So guess what I can try here? IPCS-AM. Let's go into my bin directory. Now I want to see if this snaps the machine out by freeing up memory. So that memhog now was stuck on trying to trim the slab. Now the question is whether it's going to come back at all. PS-EL. I'm looking at the WChan. There's my memhog that was trying to run this whole thing. I'm going to go into crash. Oh, segmentation fault. Not too good. Oh, did I get a response coming back? Let me do a Control-4. Now I've got to reset my terminal again. Let's see. Yeah, that reset doesn't work. You know, there's only so much time in the week, and I got all these lectures and topics to deal with, but I've told Jeff before, I'd like to have a bug class where all I do is throw problems at you and you figure out what I did and go through this analysis process that sounds like Thomas was interested in the first place. Yeah, we already saw Mamhog was stuck on shrink slab. Shrink slab. Shrink slab. Remember I said it's going to try to shrink the slab first. These other things, these code 5s are still in. Here's an RM dir. A lot of RM dirs going on there. So I was deliberately creating a slab metadata pressure situation. And even though I'm removing directories right now, there's still a lot of contention, clearing inodes. There's still a lot of contention on the slab, and I was interested in buffmem, the buffers raw IO. And here's an XFS make dir, journal force commit, log weight commit. And that's what we were seeing before the memhog for a push. Well, let me get out of there here. So I still have response here. Let me bring up top. Again, through the serial console, I got a problem that's not showing everything. I got sync buff here. I got something running. That's probably, let's see what's at the top. Let me go to F and get rid of the priority and the nice and the share. Now I can see things. So again, I'm still in the metadata situation. There's my RM running. My system time is much lower, but I still have the IO8. Oh, XFS Reclaim. That's a trim of the slab. Buffers are small, no swap. I'm still close to out of memory in the system. So everybody has a different bottleneck right now. And some of these bashes are stuck on XFS. Can I get into crash yet? I'm expecting crash does raw IO. Looks like I got in that time. PS-E, grep for memhog. Oops, PS, grep for memhog. Backtrace on 24141. Oops. And it looks like memhog is still stuck in shrink slab. Now those unattached shared memory segments are gone. My cache is still pretty big, 30. But I look at now, I do have a lot of memory free, but I'm still got a lot of things stuck in trimming the slab. And the slab is not trimming. There's almost a point where I'd like to take an actual dump too. Take another Arch KDB and take a dump and send it off to tech support. Okay, I'm going to go into dev shmem. Let me remove that big file. Okay, cat/proc/mem info. So my slab is just stuck. So I got half my memory available now. Only 62% used, but I'm still in a memory trim situation. See if I go to top. I should have done this before. Let me see. T Shift W to save it off. So those are the things that are running, but not the things that are sleeping. That's why I was trying to use crash and that sort of thing to look at the sleeping processes. Any thoughts or comments at this point?
So in particular, you're expecting that you should be able to trim the slab because it says it's reclaimable, right?
Correct.
Okay.
And at Oak Ridge, they had 9 gig that was unreclaimable, and it was a size -16384, and I made the assumption that that had to do with GPFS caching, which would also be spread round robin across the machine and not be affinity aware. So those things that were in the trim situation, I'm just looking here, 46, 49, 36, 34, 36, 20, 5986. It's just bouncing back and forth. So on one hand, I've got a whole bunch of things. They're trying to get memory, but they're stuck in the slab, and then I freed up memory after the slab was trimmed. But they're still stuck in the shrink slab area, and the slab is under pressure still, growing and shrinking. Let's see if *V shows anything. 22, 31, 39, 48, 55. Looks like it's still growing there. 764, 40216, 264, 244, 252. The size of the slab is just bouncing back and forth, but the assets seem to be increasing still. 70, 78 directory entries, 428. Both D entries and inodes are growing. So here I'm trying to trim the slab, and at the same time I'm trying to grow the slab. Okay, let me do a kill all on code 503. Now we're into RMs. Still showing hot log activity, at least the XFS log in this case. And I'm still not getting a response here. Quit, crash. PS, rep for memhog, BT on 24141, and it's still stuck in the shrink slab.
Does crash have a kill as well?
I don't think so. I don't remember, because you can kill outside of it. Let's just let me do a help here. I don't remember there being one there. Now, crash can get additional commands added to it, and maybe somebody like Steve Champion has done a kill within crash. Okay. You can send a signal, I guess. Let's do help signal. There you go. That would do it. Right? Oh, it's displaying signal handling data. not actually sending a signal is what it looks like.
Right.
Yeah, it's just printing it out.
Because from your terminal, you've sent or sig term by doing Control-C.
Yes, and that was not being picked up, correct. I did finally get a response back when I killed all these RMs. And what did that do? That reduced all contention on the slab. So before I was in with code 5s, and then I was in with RMs, and once I got rid of all that slab contention, let's see what's happening now. cat/proc/mem-info. So I still have a large slab, but the Control-C finally got picked up is what I'd say.
Yeah.
Let me try this again. By the way, I need to do this. See what I got for cache? 838 meg. It's not what I have here. Top is adding the slab to the cached field for a total. That started in SLUS 11. So that cache field there, only in top, is including the slab. So there's my memhog running. *v1space5. I'm just wondering if I'm there yet. *r1space5. I'm waiting for my memory to get used up and then to see about the trim. Top. How big is memhog? It's only at 39 gig right now, 40 gig. I'm waiting for it to hit the slab and see if we can get things down. And yeah, I saw somebody run menstat. That's kind of nice. Again, I'm able to modify that script to look at particular things. So what's the slab doing? 7621856, 8687. I'm really not seeing the slab shrink there at all. Not until I actually hit a trim. Shall we try a BC free, Jeff?
I'd like to see that, yeah.
Oh, let me see if PCP is responding again, by the way. Once I got all that slab pressure out of the way. And again, networks are in the slab. Network buffers, network traffic. Looks like we might have just hit. Looks like we're into a slab trim situation first. Let me do a watch. Actually, I can see it right here. There, we can start to see the slab getting trimmed. But this time I don't have the pressure on the slab from the metadata. And my interactive response is struggling now. But let me just do a BC free-F. And see if it affects the intensity at all. I'm not seeing any quicker trim occurring because of the BC free. And I doubt I can put it in the background. By the way, I go to DMZ server so that if I log in to something from there, when I log out, I go back to DMZ server instead of losing my PuTTY window. Okay, I can get a response. and I'm able to log in pretty good. Most of that system time right now is going to be, let's go back here for a second, is going to be the trim occurring. In fact, you can see when it started right there. So all that system time is my trim. Let me do a perf top. Cross my fingers here. There, I'm just breaking out real quick. So there, all that system time right now, we've got some sort of right lock failed going on. Don't know what that is. But here's my Inode Reclaim. Here's my Radix tree. This is all stuff trimming the slab. So most of that system time appears to be some reclaims going on from the BC free, or I'm assuming it's the BC free. Look at, we started our trim right here, but it was after I did the BC free that I got a bigger bump in my system time. And the other thing I was going to do was a PS-EL and grep for BC free. And oh, it's runnable. It's not sleeping. I thought maybe it'd be a capital D, but notice I cannot break out of it. Let's go into crash. I need to wrap up this demo and get on to the lecture portion. It's hard for me to find the balance between lecture and demo and lab, but I think the demos are constructive. Okay, PS, let's grep BC free, BTA on 25657. Oops, BT, sorry, 25657. So it's not sleeping, it's running all the time. So again, we're not able to catch BC free in a stack trace because it's running all that system time. And the only way we can profile that is perf top. Now, there is a man perf. I'm just curious here. Perf help record, and you have the ability to attach to a PID. Slab's still coming down. I didn't unfortunately time it, but we've been trying to get that slab down since before break. By the way, we did push stuff out to swap when we hit the memory full condition too. So in the trim situation, stuff went out to swap as well. Any other thoughts or ideas right now? First of all, let's do a top sys. BC free. Also kswap D, which is our memory manager, and that's where I need to get to today. And there's my memhog running. BC free, memhog, kswap Ds. So all of our system time right now is due to memory management and memory trim. I'm just wondering, perf record -P 25657. Just cross my fingers here. I don't remember if I had a time ability too.
Memhog just stopped printing, Dave. Nope, no, it's printing again.
It's stuttering. They're stalled out again.
Yeah, but I was just wondering whether or not the perf record.
Yeah.
Oh. There you
I
go.
just broke it out. I was looking for a timing option on there too. Perf, help, record. Instead of breaking out, only the perf top so far has been the one that actually hangs. So I was just trying to see if a perf record would get me information on that system time. So there's my PID, append force, output name, inherit children. This one you often have to use to reduce the intensity per thread, statistics, data, no data. Nothing there that says how long I'm going to run the experiment. Now I'm just LT. So perf report. And there we got our system time again.
Cool.
Now this is shrinking the data cache, but here we can then see the Inode Reclaims, and these were all in the upper percentages there. Again, generic locks, but here's my XFS Reclaim Inode. And remember in the slab top, it was, even though I had extended 3 activity going on, most of the slab was XFS. SAR-V, 1-5. So I can see the D entries going down, and I can see the inodes going down. Where's my slab now? Looks like I'm down to 27. So I was wrong, I'm down to 41. SAR-big B, 1-5. Here we can see the pages being freed. We can see some scans going on. And it looks like 100% of the pages it's scanning are being reclaimed and trimmed. But it's still a low intensity trim. Let me go back to here, back to memory. Let's see what, that was on a file system basis, but we're not going to be able to see anything there. So we can see the trim pretty good here. Now, Jeff, or both of you, I guess, there used to be a zone reclaim timeout capability. Let me just go to VM. There is a zone reclaim mode. Again, here I had slab ratio up high. Zone reclaim mode, but there used to be a zone reclaim timeout that said, if I can't reclaim quick enough, I'm going to go off node.
Huh. And
that isn't there anymore. So the question is, as MemHog is trying to trim, where are the pages allocating? Is it still node? We're basically past the node size anyways. But when I'm trimming, I'm going to try to stay on node for my trim first. But there used to be a point where it says, I'm tired of trying to trim my node, I'm going to go off node. And that's where we would need to look at node info. We don't have time to do that right now. Any other thoughts right now? So imagine an application that's trying to run and then sitting there waiting for this. There, I finished my, that was already 13 minutes that we've been trying to get our slab back. We've been trying to get our memory back for half an hour. And we're only talking about a 70 gig slab, which is small on a 16 terabyte machine, but it all still goes back to where your DF-I numbers are. So what did I have here? 11 million inodes there, 66 million inodes. Most of the slab was this. So this is giving me a scale. So we're talking about 70 or 80 million inodes, and we're in trouble. And keep in mind, it could be an NFS file system out there that has a lot of stuff. In this case, we don't have a whole lot of stuff on my NFS server. I'm just waiting to see what happens here. Now that BC free I'm expecting is still going. There it is. It's been running 11 minutes of CPU time already.
So would it make any difference if you were to go in to, I mean, we know it was writing to temp because we were looking at it before, to go in and clean up the file system. I don't think it would make any difference, right? I mean, it's got...
But to me, that would be worse because that's putting activity and pressure back on the slab. So
Right.
if I go in this situation where my slab has sucked it all up, if I'm going to try to clean the assets up, they're going to have to come back into memory, creating more pressure on the slab while I'm trying to trim the slab. So to me, that's kind of a double whammy. Again, don't get into this situation in the first place. Would you see my point?
Yep.
I am trying to trim, and then if I try to do something that's going to need the slab, it's going to be in a resource that's bottlenecked. And I start off the week saying, look at CPU, look at memory, look at disk, look at file system, buffer, cache. And we've been pounding on the file system piece all week. And that was impacting interactive users and everything. And again, when I run out of memory, I'm not in an out-of-memory killer situation. Even though I was out of memory, I was stuck on the slab trims. Okay?
Yep.
I think I'm pretty much done here. Here's where I cleaned up my shemem, if I remember correct. No, I guess I just killed the application here. That's where memhog finished, and I'm still in the BC free trim going on. And I'm still down to about 20 gig. And what do I got here? I've got 5 minutes worth of data just there. So if I tried to reboot the system, I would have been in the same problem of having an hour or more to do a shutdown. And that hour was even with the workload being killed. I still have to deal with the stuff that's in memory. And again, Thomas, I'm just pointing out, like you pointed out, these huge memory systems, the bigger it is, the more I can abuse it. The more CPUs I have, the higher the intensity of the contention and the pressures that I can cause. So that's where we get into CPU sets and starting to contain this stuff. Now, ITSI init.d, I don't think this is on Floyd 3, but Jeff, you've got this on Floyd 1. Maybe I don't have it on Floyd 2. I'm going to go to Floyd 1. Oops. I'm just, in my other classes, we call it nothing.local, but it's just a customized init script. And I am doing this, first of all, Jeff, this was a local hook that I put in mind to deal with both SGI XVM and whether I had extended 3 or not. Because for extended 4 would not load by default. So I did it this way rather than some other way. So here, end of the day or something like that, I want to put all this stuff into a boot CPU set and then create an interactive user CPU set. Are both of you okay with what those 3 lines are doing?
Yep.
Yep.
So I'm jumping ahead while I'm live here, but then in more itsy boot cpuset.conf. Oops. Huh? That's strange. What am I doing wrong?
Well,
Must
if
not
you're
have
looking
had one here yet. Okay.
your user CPU set, it says a different name.
Yeah, I know, but this was somebody else's system. Take a look at Floyd 1. So when I grabbed the local script, I was thinking that I still had this set up. Basically, the student last week did not do the CPU set lab. So let me get out of here. So I'm going to do a CPU map. And what I want to do, and I've got a PV to make these sockets partition relative. So this is the physical socket, not the partition relative socket. But I want to put that socket as a boot CPU set, and then this socket as a user CPU set, and then these I can use for PBS. Okay?
Yep.
You okay, Thomas? And again, I want to be socket aware. So I'm going to create a vi itsy boot cpuset.conf and CPUs 0 to 3, and then what was the other ones? 14 through 19, I think. Let me just double check. No, 16 through 19. And then I just want 0 for the socket, and then I'm going to put in verbose. You okay with what I'm doing, Thomas?
Yep.
Now I'm also going to edit my itsy.elilo.conf. Thomas, have you heard of uvconfig?
Yeah.
So it's going to muck with what's in the boot EFI SUSE directory. And in reality, you want to make most of your changes in the itsy sysconfig uvconfig file. Because uvconfig is going to run on every boot and every shutdown and make sure that UV-specific parameters are in there.
Okay.
So I'm going to take my first one here. 1, 2, 3, 4, 5, 6. And I need to do a init equals /sbin boot CPU set. Is that right? I need to check the syntax. Do a man on boot CPU set. SBin boot CPU set. Everything looks correctly spelled there. Now when you're in a React will set this up, and there is a React command that runs instead of boot CPU set. But it does the same thing at the API level. Okay, and then I'm going to put in a different label here. I'm also going to protect myself and just make this the default on next boot. I'm really trying to get ready for tomorrow because we need to talk boot CPU sets and NUMA and stuff tomorrow. So the next time I reboot, I'm going to be containing myself in a CPU set.
Now, because you wrote it to Etsy, it's still not in boot EFI SUSE.
I'm going to run the elilo command to sync it up, if that's what you mean.
Yeah.
But uvconfig should be doing that on shutdown anyways.
Okay.
But I am in the old habit of editing the boot EFI SUSE, always knowing in the past that that could get stepped on by the elilo command. So in reality, some of it you could put in here as well. In fact, here's a UV kernel command line with all the different options. Okay, but UV config should leave what I added alone. But if it were any of these other things, I would have to edit in the UV config file. Like fixing crash, is crash in here? Or again, no BAU, getting rid of that. Everything since PTF2 kernel, the broadcast accelerator unit does work. Does that answer your question right now, Jeff?
Yep.
Now the other thing I needed to do was I had a user CPU set.
Okay, you want to copy it from, never mind.
I'll create it from scratch. So CPU map, this time I want 4 through 7, 20 to 23. Four to 7, 20 to 23. And MEMS socket 1. Good enough. Okay. Now let me just test that. First of all, check config, nothing underscore local on. That's okay. I'm not worried about that at all. SMEE GUI also, or the SMEE stuff also has syntax problems at the top. I don't know if you're aware of this, Thomas, so let's just take a look at one. Network, for example. Oh, let's do the nothing. So it's complaining about not having this. And notice, Jeff, in my example, mine is configured for both Red Hat and SLES, because I've got both the check config syntax and the INS server syntax.
Right, and the way you've got the source to function library here, by commenting out the Red Hat, there's actually a way to make it so that it is universal.
Yeah, I went to a website to say how to make it universal and tried to integrate that example.
Yeah, it's a detect what's there.
Yeah. So anyways, I've tried to make mine a little bit more generic, but that's what it was complaining about. Now let me try a service, nothing. Oh, before I do that, ls on dev CPU set. And PBS Pro is there right now. Let me do a service PBS stop. And then my service nothing underscore local start. Now, Jeff, do you know anything about Torque and Moab having issues with CPU 0?
No, I've not heard that.
Troy was complaining about that some Torque and Moab at that site needed to have 0 within the Torque CPU set or something. There were some issues going on there, and I didn't really follow him. I had not experienced that situation myself, so I didn't pursue it any further. Dev CPU set. So let's see, doesn't look like I actually got my CPU set created, huh? Okay. Just check config down. Let me just double check here now. Does show on. Let me edit it here. I do have a set-x in front of it too. something's not right.
Yeah, because you're not even getting your echo at the beginning.
Yeah, I know. This was working, but let's just. Oh, that's why.
Exactly what you said to do.
So I should probably modify my script to warn that there's no sysconfig file. Let's just see if that makes a difference. Okay, so it's cpset_test.conf. I thought I did create that, but let's just check it here. Huh. What did I call it then?
I forget.
cpset_user.conf. Oh, and the other one was test, I think.
Yeah.
Okay, so now it did create a user CPU set. Okay, you okay with me, Thomas?
Yep.
So now I'm going to, first of all, this is what's called the global CPU set. I'm going to cat/proc/$$ CPU set, and I'm in the global. Okay? And if you notice, what I did in my script was only SSHD was going to be put into the user CPU set. So if I'm coming in through the serial console with the TTY, I won't be in the user CPU set, I'll be in the global. But if I log in with SSH, then I'm going to be in the user CPU set. And that can create a big difference depending upon where the pressure is, where the contention is. Okay? So now I'm going to go into user and cat CPUs. So there's my 4 to 7, 20 to 23 CPU map just to check. 4 to 7, 20 to 23 for my second socket. I have not rebooted, so I don't have a boot CPU set yet. Cat tasks, that's just SSHD. Somebody want to try logging in right now? Cat mems, socket 1. cat/proc/$$ /CPU set, and I am in the user CPU set. And I can see other PIDs that are going on there. Now I did write a CPU set-q script to print things out, and now I'm able to actually see a little bit more information about what's in that user CPU set. And this is not working yet. I still have some problems here. But now I'm actually running a PS on each thread that's in the CPU set. And then I'm trying to print out the affinity mask. And that's coming out of /proc/$/status. So I'm just grabbing that for that particular PID. And then the other thing I'm doing is running a DLOOK on that particular PID. But I still got problems with this script in the verbose mode. So then I'd be able to see what node things are on as well. Okay, service PBS start. I'm going to run that CPU set script again. Now I see PBS Pro. Oh, we don't have a boot CPU set yet. So it grabbed the CPUs that would have been in this boot CPU set. On reboot, that will go away. and it will reconfigure itself. But I wanted it to be 2 and 3, and those CPUs. Actually, we'd still have the ones that were the virtuals for that particular processor or cores. Now, these were the things that I was talking about. Some sites have a set UID program to allow that to be changed by default. But in my opinion, with these large memory systems, if I can hold it on socket, I don't want to do this. I'd like to see those flipped. But that kind of needs to be on a per process basis. But again, this is spreading my network buffers across everything, and that's going to create interconnect and lose my locality and go across the interconnect and create interconnect connection. Basically what I'm saying is, even though I've got a boot CPU set, all my slab and all my cache is still going to be spread across everything, creating I/O contention. Now again, I have a dlook-summary. Came from John Barron, and I've got an RFE to get it actually integrated into dlook itself to give summaries. So in there, it's basically now telling me where is my data. So that's what I'm trying to get with that CPU set -Q, to be able to go through something that's multi-threaded. Again, I have a problem in getting parent PID and TIDs and that sort of thing going. But to be able to run a PS on a thread, be able to get the affinity mask for that thread, and then be able to get the nodes that thread has data on. That's what I'm trying to do. And be able to do that on a per thread basis within a given CPU set. Anyway, I also modified it so I could do a CPU set -Q and put in a PBS or TORC job ID and be able to do this on a per job ID basis instead of system-wide. Any questions? I think we're done with demo. Went a little longer than I wanted, but I'm hoping that that was constructive.
Sure.
And my slab is down to nothing now. I didn't time the whole thing in the end, but oops. So I'm down to 622 meg. And some of that is still reclaimable, but I'm not going to worry about that. BC free -F. And that one came back pretty quickly, yet we still have some that's reclaimable. F. I want to get rid of some of the stuff. Oh, wait a second here. Okay, there we are. So I have a quiet system, and by the way, all those crons and everything cleaned up as well. Let's see what happened here. SAR. 1050 to 1116, 20, 30, 40, 50.
So it had the data, I mean, it still had the 1030 data to write.
Apparently.
That's pretty wild.
And there we can see the trim. So that was the BC free that did all of that. So this go.bottle is just my way of creating a large, intense workload. I'm going to put it back into temp real quickly here. And then what I got down here is number of concurrent copies. So normally what I do is I run a bottleneck stress and go 1 copy multiple times, 2 copies, 3 copies, to actually have a controlled bottleneck curve that I can measure and collect data on. But I've modified it just to fire off a storm at the beginning to storm the system. Okay. And let's just see what happens here now. Again, that code 5 is just a thing out there called postmark. Let me get rid of free here. And look at what's going on here. There's the slab, and we also have dirty going on here. But there's the buff mem, that's the journaling activity. Looks like we have a flush going on here. So we're going from dirty, barely visible here. Let's see if we can see the writebacks here. Get rid of buff mem, get rid of dirty. The green are mapped. There are the writebacks. Now this is what I call the trickle flush. Let me put the dirty in there. So you can see the writebacks just riding on the top of the dirty. But look at how quickly, as soon as I fired that off, Jeff, how quickly my buff mem grew.
Mm-hmm.
And again, that's due to the journaling activity. What do I got for top? And again, showing me a hot kernel, hot journal. And all that IO8 is the dirty data being flushing. Everything else is stuck on log weight, interestingly enough, even though I do have, let's see if we can see it here. The buffers is growing from the log activity that's going on. 37% system time. I'm going to do a perf. Let me do, first of all, top sys. K-journal D looks like most of the system time. I'm going to do this real quick. Again, I'm not in an open MP, so I'm hoping that I'm safe here, but I get in and out of perf real quickly. One, let me get one more sample. Uh-oh. Experiment over, it looks like. Let's see if the system, the only thing I can do is UV-con, P2, control right bracket S to steal my console. Notice it showed that the console was stolen. Escape shift KDB, unresponsive. I did hit it. I waited too long. Power NMI, reset. Oops, NMI P2. And that is not going to be responsive as well. Even NMIs are being blocked in the particular code. So let me just do a power reset P2. And I'm going to come up with a boot CPU set this time and then move to lecture. That was about an hour more than I really wanted to do in terms of carving out my time, but one of the things that's happened, Jeff, is page cache, like dirty and stuff, they've gone to bytes, but not for min-slab ratio. Control right bracket S to steal the console. I just want to make sure that I should be booting in the boot CPU set by default anyways. So I want to catch that to prove that. Thomas, I added a verbose in the ITSI bootcpuset.conf file that should show when the kernel, before init actually running, when the boot CPU set is actually set up.
Okay.
Now, ironically, I was on the system for 2 days before we realized 4 sockets of the 16 blades did not have memory in them. And it was only when I looked at the global CPU set and saw 4 nodes missing that we went back into the BIOS and found out that the BIOS was not finding any memory on the socket. Then they later pulled the board and found out there was no memory in the DIMM sockets. Somebody had shuffled memory around. Harvested memory was the word they used, and did not do it in a socket-aware harvesting. And the CPUs were there, by the way. They came up on the other socket's memory.
So the CPUs actually worked? I thought we couldn't do memory or CPU-free nodes on this platform.
I'm sorry, what's your question?
They didn't
have
harvest all the memory, just some of it.
Oh, just some of it, okay.
So
Yeah,
the
you're right.
socket came up on the other socket's memory on that QPI.
Yeah.
Oh,
That
okay.
surprised even Pat Donlin and people here in Egan, because
Okay.
nobody had thought or hit that yet. And that is a degrading situation. Now, at that particular point, there is no console, so there's no way of writing out a message saying these sockets are missing memory. Now, if there was a memory hardware problem, at the BIOS level, you're going to see it retrying that memory over and over again. But their real concern was these IRUs were on jets doing data acquisition and vibration, stuff like that. They wanted to be sure that everything was running in a fully supported, fully populated memory situation. I never did file a PV or an RFE to deal with that. I just told a couple of people here in Egan. Okay, now I'm waiting for a CPU set verbose message coming up, and then we'll move to lecture. And by the way, in this particular scenario, they didn't want to wait an hour for a boot to find out that they were missing memory on some sockets. Okay, we should be kicking in about now with the boot CPU set. Remember we hung the system, so we did have an inconsistent file system in there. And at the time, I was storming it too. But here's what I was trying to show you. So that verbose enabled is now showing me everything that got seen. Jeff, this is another thing that I've been trying to complain about. It was supposedly fixed, but I'm still getting this report this as a bug message from the firmware.
You have the latest firmware?
Yes. Well, it was latest at the time that they said it was fixed. Okay, there's my, oops, the user CPU set failed. PBS started before it. So I've got a boot order problem. So VI, it's the init.d, nothing. I need to run it after PBS in this case.
No, you need to run it before.
Correct. Thank you. Required start, no. Should start. Let's see, what's a good way to do this? Maybe just move PBS later.
Well, you can say, tell PBS, required start, nothing under local. Except it doesn't. No, it does that down later.
Oh, I just can't type anymore. Okay. So I'm, let's see. Service PBS stop. Service nothing. underscore local stop, just to be sure. I'm not going to clean up that test thing here. Start it, and then let's see, looks like it was successful. Now my service PBS start, and hopefully on the next reboot. Okay, let me just check now. CPU set dash capital Q. So my PBS Pro, upper half of the machine, nodes 2 and 3. My user CPU set here, node 1. And only SSHD is in it right now, and everything else is in a boot CPU set. So I'm just using that CPU set dash capital Q to quickly, show what the CPU set configuration is. Another thing I want to do here, it's the sysctl.conf. Let me drop, now again, I'm going to be running in CPU set areas, but let me drop the slab ratio. Now, I don't think it'll take a 1. I think 5 is the minimum it will take, but I've not confirmed that in the code. And I'm just going to keep everything else the same. Now, tomorrow I'll use PBS and do some things under PBS to take advantage of the other 2 blades for the CPU set. And now let me do my service boot.sysctl. That should do it. Start. And now my sysctl-a grep for slab, and it's now down to a 1. Any questions?
Cool.
So let me go to lecture here. I'd like to do lecture, take a break, and then come back. And I'm going to be pushing into the time frame we had yesterday, it looks like. So are we okay to just get into this module, flip through it, and then take a break?
Sure.
You okay with that, Thomas?
Yep.
Jeff knows I'm a little Simon agree. I really push the time window that I've got here, so I appreciate your patience with it. Particularly
no
lecture
problem. I do have to jump off in about an hour for a customer presentation I have to give.
Okay. So let's get through this quickly.
If not done in an hour, I'll just grab the recording later on.
Let's just see how quickly we can get through this.
Okay.
So XFS, both of you have been around for a long time to know XFS pretty good. I just want to flip through these slides. If there's a question on anything, it's your chance to ask questions. So basically, we know what a file system is, a way of locating the data on the physical disk. We map a file name to the data location on the disks, and it's up to the file system to figure out where it is, hopefully in a contiguous fashion so we don't have extra head movement and fragmented files. Created on a partition or logical volume. And remember I said CPU memory disk, file system buffer cache. So right now we're into the file system buffer cache portion of analysis. When I say file system, I mean metadata. So file system is in the slab, but that's super blocks, directories, and inodes. Those are contained in the slab. And by default, that slab and those metadata objects are spread round robin across the machine. So Jeff, in that prior example, my code 5s would have been able to step in other people's CPU sets and create contention on their memory and impact their user CPU time. So basically, we're just showing a file system drawn out. IRIX naming conventions still. Now we know file types, the ls-l, the first field, will tell me what we have. Dash for regular, D for directory, P for named pipes. And if you're not aware of this, PBS and Torque are using a named pipe. QSub and the scheduler are actually I think it's the server, have a named pipe to talk to each other. Then we've got character devices in /dev, like tape and terminals. We have block devices like disks. So a block device says we got to chunk or block the data. And in sysblock, we can find out about those block devices. And XVM itself is also doing blocking and considered a block device. Then we have L for symbolic links and S for network sockets. And sock list is useful. And again, I was mentioning earlier sites that had problems disconnecting from a database engine, leaving a zombie around that had an open socket, and the zombie would stick around until the timeout on the open socket occurred. And that was impacting performance. So XFS is a standard feature really in both kernels. And by the way, the Red Hat installer now allows an XFS root. It did not used to do that. So in RHEL 6, when I come up with the installer, the disk Druid, it does give me XFS as a file system choice for root. But in Red Hat, it's not built into the kernel, it's a kernel module. So I would say that it's still a standard feature in both, it's just Red Hat, it's a kernel module. What's not supported in SUSE is extended 4, which is now your default root for Red Hat, is an extended 4. And extended 4 basically picked up XFS features. So it supports file systems spanning multiple devices. Again, it has a journal file system to protect your metadata tree. It does support 64-bit file capabilities, but that's not the default. But that allows me to get bigger files and bigger file systems. And one of the key things that Extended 4 picked up from XFS was the concept of extents, which is actually originally based upon a Berkeley file system. And maintain and backup. The maintenance and backup, again, are raw I.O. XFS dump, XFS restore are raw I.O. will show up as buffers. So we did this yesterday, makefs.xfs, and I did do an external log in my case. But in my example, it was for example, I didn't have my file system spread across disks, and I didn't have my log on a separate disk. So I'm not able to prove the improvement that an external log would have. That was just for practice. I'm not sure, and I don't know if you got hard copy or making notes, I'm not sure these are right. I've been told they're wrong, but I got it from somebody else. But on a 32-bit, basically limited to a 1 terabyte, 64-bit getting up to 9 exabytes for a file, and 18 exabytes for a file system. And I converted those into terabytes, 9 million terabytes or 18 million terabytes. But I got to double check those numbers. There are a couple of sysctl parameters that impact XFS. I don't really care about them. But in IRIX, when you actually created a file, the mode came from UMask in IRIX. There's also this SGI dbit inherited regardless of the process group ID. And then chown to allow users to chown away from themselves. So at the XFS layer, we make a system call like a read, write, open, close. Then we've got our I.O. manager for reads and writes. If we are growing or shrinking, we have to call the space manager. If we're making or destroying directories, there's a directory piece. And anytime we're changing metadata, we have to call the transaction manager, which is our journal. Basically, a transaction is a collection of metadata changes. From there, we go to the buffer cache, then the volume manager, and then the disk driver. And I got that same slide 3 times. So PCP does track the number of read and write system calls. And again, this is what we've been pushing on, directories and inodes. dentry_cache we were seeing. You can do a man on slab info to look at that proc slab info file. And we kind of page through it to see the other types of objects in there. And we've been using sar-v and slabtop-s-c to monitor the directory information. And a directory, dentry_cache, has an inode number and a file name. By the way, first of all, a man on XFS_DB will give you structure definitions and fields in a structure. So you can do a man on XFS_DB and get information about how this thing is built, what fields it has. If you are interested, I've got to dig for it because it moved, but there is a training website off of oss.sgi.com that was put together to train Novell engineers years ago for XFS. But that information is still there, but there is a newer website for XFS, and they are maintaining a newer URL for structure information on how XFS internals are built and stuff. Not something that I deal with here. So anyways, we get an inode number and a file name, and from there we get to the inode. And from the inode, we then get to the data. Now, extended 2 and extended 3 were what we're called indirect block mapping. In that case, you're following a chain of events to get to your data. So this is an extent list. So we were using this earlier today even. I was using that XFS stat script that I have and going into the proc files, I think it's procfs XFS stat. So a lookup, directory lookup to find things. If it wasn't there, we got to create it. And we were seeing creates the other day, and removes, and then a get dient, an ls on getting a directory entry content. Inodes then, we have 2 inodes. One is in memory and one is on disk. So I was using ls-l, df-i, and xfsdb we have not used to look at the disk attributes. And then one in the slab, and that's what we had been looking at, was slab top. And there is an xfs_inode structure there. And we're also looking at star-v to see what was in memory. Now for XFS, it's XFS syncd that's flushing modified inodes, but not the journaling activity. That's for the inode information. So again, a man on XFSDB will give me structure information. And this is just showing what might be in an inode. Again, an ls-l is printing out the attributes that's in the inode. So that XFS stat script can tell me about looking for an inode in memory, times we found it in memory, number of times the inode was busy, so we couldn't do anything with it. Here we had misses. We could not find it in the slab, so we had to go to disk to get it. But we might also have multiple inodes. Keep in mind, I had a 70 gig slab that was all inodes, but if you look at the size of an inode and the number of inodes that df-i were reporting, there's redundancy going on there. There's the inode's in there multiple times. So there are times we missed but found another inode. This one is an important one. Unfortunately, we weren't able to see it here. But I have had cases where watching IG reclaims, and you can actually watch the system stall out during a large slab reclaim. We didn't experience that in this class, at least not yet. But watch for that one, particularly when you've got a large slab. And I was getting maybe 10-second stalls when a reclaim would occur. And you'd see the system time go down, you'd see the IO go down, and you'd see the system time go up as it tried to do the reclaims. Number of times inode attributes are changed, and again, number of times inodes are being flushed, number of times they're clustered, or number of times they're not able to cluster them. So when we flush inodes, we try to group them into a cluster. File attributes, not the same as chatter, which are things like the immutable bit. These are things that are metadata about a file. I've got a couple examples here. And there are some statistics in XFS to say whether attributes are being manipulated. So here's the key thing, and I wanted to get to this with Jeff in particular. When I do a concat situation, I still have allocation groups to spread things across. So in your example, Jeff, when we were talking about one file being created, it'd stay in one allocation group, then the next, then the next, then the next. And that's when you get into striping. But if I have multiple users, the allocation groups are the way to get multiple files spread across everything. Now I'm getting into sites that have too many allocation groups. So if they concat a whole bunch of RAID devices together for capacity, they want to be able to get all the drives involved in a given day to spread everything out, but they need, if they have too many allocation groups, it takes too long to rotate between allocation groups. And that's where the skip allocation group concept comes into play. By default, it's a make dir that's going to rotate allocation groups every time I make a directory. And again, XFS stats shows you the intensity of directories being created. Also, there is an XFS bmap that will tell you which allocation group your file is in. So this is just trying to show every allocation group has its own metadata. One of the key things to an allocation group, other than distribution, file metadata is locked on a per allocation group basis. So if I have more allocation groups, this allows more metadata changes concurrently at the same time. So if I have less allocation groups and have a lot of like Barstool News, Barstool Mail, I'm going to get contention on the metadata. If I have metadata-intensive file systems like Barstool News, having more allocation groups can spread out the metadata intensity into their own allocation groups and reduce contention on the allocation group. But if you get too many, then it's going to take a long time to rotate between the allocation groups. And that's why I use a skip with an odd number. So this is just showing in an allocation group we have our super block, which is makeFS. Then we have a pointer to the allocation free blocks, a pointer to the inode B tree. A B tree is just a fancy search algorithm. In fact, B trees are obsolete. I remember a couple XFS engineers were talking about redesigning XFS to use red-black trees. That's the newer search algorithm. I basically describe B tree as being like a sign at the fork of the road. If I don't have a B tree, I got to try every fork when I hit that roundabout or hit that intersection. A B tree or a red-blue tree gives me hash information to say which branch of this file system do I want to traverse to find what I'm looking for. Now we have two B trees here. One is ordered by block number and one is ordered by block size. We hash both of these B tree lists at the same time to find the closest block of a given size to reduce fragmentation. So I don't want to just find close, I want to find close with a given size. And again, with delayed allocation, I'm going to stall a little bit before I actually do the allocation, giving me a better chance of having a bigger piece of the file in my cache, and therefore when I'm looking for space, I can find a big chunk close to me. So that dual B tree is to reduce fragmentation, but delayed allocation is also needed as part of that, along with extent lists. Any questions? So this is just trying to show what's in a super block. I don't really care about that. And then this is just describing a B tree. And then inodes are allocated in chunks by default. makeFS assumes 4 KB file system sizes. So a default inode size of 256 is going to be chunks of 64 at a time when we manipulate them. So again, when I was talking about a large slab that is almost as big as the file system, we're going to end up with redundant inodes in there. And almost like a fragmentation going on with multiple inodes that could be loaded in from disk. And again, just to warn both of you, in DMF we increase the size of the inode for DMF attributes, which is going to make less inodes in a given block here. So this is just talking about file allocation. We rotate allocation groups every time I make a directory. The files in the inodes used to be clustered around the directory, but we don't necessarily do that anymore. That depends upon the file size of the file system. A lot of these concepts were back when we were in 10 gig drives and stuff. XFS was written on much smaller file systems in those days. Nowadays, we'd like, when it's a large file system, we'd like to keep the files away from the inode to reduce fragmentation. If I have multiple inodes and multiple files growing in the file system at the same time, they're going to tend to get fragmented. This is just trying to show allocation in the stripe volume. So I've got an allocation group here, an allocation group here. Again, every time I make dir, I go on to the next allocation group, and this results in decoupling the metadata, but I don't want too many allocation groups. If I've got too many allocation groups, an allocation group gets too small. And then I end up, when I run out of space in an allocation group, I end up going on to the next allocation group much more quickly. So it's a trade-off. Lots of allocation groups are good for lots of little files, but not necessarily the video market where you have large sequential. Multiple allocation groups are not going to help you in data acquisition where you just got one I/O stream. It's going to reduce contention on metadata storms like we were seeing earlier. Now, in this case, I've now taken 3 stripe groups and put them together as a concat. So this was the problem I was mentioning. At one site, they had so many allocation groups it'd take a day before they rotated to the next allocation group and got into the next concat object. So this again is why skip AG is handy, to be able to rotate and get off of one concat to the next and get a distribution and round robin between these concats much more quickly. And again, if I had 2 groups here, 2 groups here, and 2 groups here, and I pick a skip pattern that's an even number, I'm going to end up back into the same allocation groups. So I like to have an odd skip. So this is just trying to show file allocation when I'm less than 2 terabytes. My files are close to the inode. When I go larger than 2 terabytes, my inodes are in one zone of the disk, and my files are in another zone. And again, this is to reduce fragmentation. And there's also the ability of a rotor step capability. This slide is kind of wrapped and made a mess here. But over here, when I'm greater than 2 terabyte, with a rotor step, and I didn't like this, a rotor step says put 3 files in the same allocation group before you go to the next allocation group. That's not what I really wanted. I wanted to be able to get I didn't want to group things because now only one file can grow at a time. So if these 3 files are in the same allocation group, with a rotor step of 3, only one can grow at a time. If I put a rotor step of a 1, each file would be in its own allocation group and they can grow concurrently. So I don't see a reason really for grouping other than maybe a video server or database server where I don't have metadata activity occurring. So this is why they came up with the skip, which was more a way of distributing across the allocation groups instead of clumping them in an allocation group. Any questions? So there are PCP metrics on extents allocated, blocks allocated, extents freed, and blocks freed. Again, an extent is a contiguous piece of the file. Back in Cray Unicode days and AT&T System 5 Unix, it was a bitmap. 1 bit for every allocation unit, 1 bit for every file system block. Then we're also tracking how B-tree lookups, blocking number of block maps for where the data is, block map B-trees. I really am not interested in most of these. These I am interested in: number of bytes processed by XFS, number of contiguous buffers, and number of non-contiguous buffers. We used XFS info already, and we had an external log. And again, I even still get burned, and I was bugging Jeff about that when we were talking about blocks. It is B-size. It is not disk blocks. It is B-size blocks. And I've even burned myself in the past year even knowing better. So everything on this is file system blocks. I would have preferred calling them allocation units, AUs. That was the older naming convention for a file system block. Note in this case I've only got 8 allocation groups. This one I got 22. Notice it's var spool news, so that can be to my advantage. And this is actually an old XFS info. So we get into journaling, file system operations altering multiple objects. Traditional method of metadata updates was an ordered synchronous update, and your repair after a crash required an entire metadata scan. So I remember Craze that would be booting for 3 days as they repaired the file system. remember when my son lost a FAT file system, and it was a 100 gig drive, and it took a day for ScanDisk to go through it, and where did everything end up? Lost and found. So a journal is protecting the integrity of the file system, and instead of putting things back in lost and found, they go back into the file system tree where they belong, because the journal says where we were in the file system that we were mucking with. So a journal file system makes it quicker to go through the file system because we know where we were in the file system, and we don't go through the entire file system tree. And secondly, it is able to put the files back in the file system tree where they belong. So journaling has transaction concepts, which is a collection of metadata changes, and after each transaction, the file system is consistent. Now, this journal of the log is an ordered collection of transactions. It's a circular list. And again, it gives us fast recovery. We replay the log. A lot of people don't get this, but the mount is what does the repair. XFS repair is a last resort. The mount is what actually does the repairing. So this is what I was trying to point Jeff to. When I do have XFS log weights and things like that, the in-core log buffers, there's an FS tab option to specify how many, and it's 2 by default, and I think the maximum I can go to is 8. I've not tried it past that. And that can reduce contention on the memory, and then also the disk drive. If the log is still hot, I can move that off to an external disk. So the on-disk log is also circular. It's always written. It's only read during playback. Again, mount calls the recovery code. XFS repair is the last resort. Basically, when you do a clean U-mount, typo there, it prevents replay of the log during the next mount. Multiple in-core log buffers allow for transactions when another buffer is being written. And that was that no IC logs that I was showing you in XFS statistics. So anyways, make FS, I was showing you an external log. We already did that. And I might have needed a bigger log to be able to have a longer history with the amount of data that I was doing. With the intensity of the metadata changes, I'm not sure that the log had enough information far enough back for the intensity of what I was doing. There is a minimum and a maximum size to the log. So I was into XFS statistics, number of transactions waiting, number of async waiting, number of transactions that did nothing. These were the 3 that were the most interest to me. Number of log writes, number of blocks written, and again, this was the key one that tells me log buffs on a mount might reduce contention on no IC logs. So having more logs instead of 2 versus 8 would reduce contention on that. Now we have an action item list concept, and I was seeing AILD picking up there. This is where metadata, where the log write has occurred, but the metadata is not flushed yet. So this is, again, metadata intensive. Again, trying to characterize the metadata intensity on my file system. And I was tracking all these XFS statistics with PCP and PM Logger. And I have a tool called SPV. Now, SPV was not working on my VNC viewer version, but if you've got X11 or something, try popping up SPV and poking at it. So, by default, the log is in the middle of the drive, the point being if I'm always halfway there. But that's also going to cause extra head movement. Now, in the past, there was a site that didn't know it was in the middle, so they created an external log and put it in the middle. Now, this helped Networker, because now we had 2 partitions for that file system, and Networker fired off 2 I/O streams to back up those 2 different partitions. Again, my drives are zone bit drives, and I pointed this out yesterday. I didn't really want to put the log at the beginning of the drive, because that's where the bandwidth portion of the drive is. I'd rather put it at the end where I'm not wasting bandwidth. But it's a pretty small log. And I did it at the beginning yesterday just for convenience. Now, the hard part about going to an external log is what do I do with the rest of the drive? I do not want to put all my logs on that same external drive, or now I've got contention again. I want to decouple things. So if I make the log external, I'd like to find a dormant file system, like where you put your clones or backups, things like that. That would make sense. If I've got a clone drive, put, you know, an emergency golden root out there. Put the external log there, because that's not a busy drive by default. But the hard part is these drives get larger and larger, and nobody likes to waste a slot for you know, a 100 gig drive. They'd rather put in the largest capacity drive they can. And I'm sure both of you realize the bigger the drive, the more the data there, more contention for the data. We want to also still have lots of spindles. If a drive is busy head-seeking to something, I'm not going to get the latency I need. I'd like to get multiple spindles involved. Any questions?
Nope.
Version 2 journals are also in the middle of the Stripe group. Now, in the older days, I used to see the journal just on the first drive, and then you see that drive at like 100% busy, and in my case, I've seen the others at 60% busy. Once I got that log off that first drive, everything went 100% busy. Now, when I was talking about rules of thumb, SAR-DP, when I see service and waits low, but busy at 100%, that could be good, that could be bad. I don't know. That's the health of the system. It's a behavioral issue. But I'm going to look for head movement, and the journal could be one of them. But if the purpose of the file system is to do I/O, I would like it to be 100% busy, just productive. If I'm reading a data acquisition video stream, the purpose of that file system is going to be to stage the data and get it to the platter. I just want that to be productive I/O, not head movement. So this XFS stat script, there is a version of it in the CXFS RPMs, but basically I've got my own version. Now, I could dump all this stuff onto PCP, but again, the hard part with PM charges, I can't look at everything at once, and no IC logs at 5 might be much more critical than block allocations or block maps that are in the tens of thousands. So the important ones are buried in noise. And by the way, I did forget to do this when we were doing our slab trim, but I have a VMstat script as well to look at the reclaim information and the scanning and the inode steals and stuff that were going on in the VMstat file, proc VMstat. I didn't get a chance to look at that, maybe tomorrow. So when we make a file system, we really don't have much choice nowadays because our default page size now is down to 4K. And that's the default for your allocation block size. So you really can't do much there. You can manipulate allocation group count if it's varspool news or metadata intensive. I could have more allocation groups and therefore concurrent metadata changes at the same time. But I got to make sure that my assets get distributed across those allocation groups. Here's the one we were using and hitting. And there is the ability, again, since I don't have a 16K byte or 64K byte page size anymore, I don't have much flexibility here. But this was meant to allocate directory stuff in larger chunks to reduce metadata fragmentation. Again, before, if I increase the block size on my data, the metadata also was that same block size. So if I had a file system with lots of little files and increased this one, then I'd end up wasting disk space. So they created the ability to have a small block size for the data, but a large block size for the metadata. But unfortunately in x86, I'm limited to page size and really don't get a payoff there. What is a benefit to me now is I can allocate and strike width size. So this would be relevant in the video market, the data acquisition market, that sort of thing. Increasing block sizes reduces the risk of fragmentation, but at the same time, if they're small files, I end up wasting disk space. So a lot of this stuff, when my page size is 4K byte, I really don't have the flexibility that I have had in prior XFS implementations, where we were 16K and 64K page sizes. So originally I could go up to a 64K allocation size. So here's an extent concept. An extent list, XFS BMAP will print it out. The first field is the extent number. The second field is the logical offset into the file. The third range is the physical location in the logical volume. This is logical volume, not physical. But if you look here, let's see, I'm going from 636 to 352, up to 551, and then down to 12. So it's kind of not only fragmented, but going middle, beginning, middle, beginning. Now, Jeff, when I was at USPS, we were running XFS BMAP on some of their Oracle, what are they called, AFS files, and some of them were fragmented, and some were okay. Try watching an NFS write and running XFS BMAP on the NFS server, and you'll see some interesting things. Don't have time to do that right now, though. But watch a NFS server write to an XFS NFS server file system. Now, it's not documented, but BMAP has 2 Vs and also 3 Vs. Excuse me. So when I get into verbosity, I also get the allocation group they're in and the offset into the allocation, and the total number of blocks in that extent. And with 3 Vs, I can see if that extent is boundary aligned within my stripe. And that's, again, more for the video server market. So fragmentation, don't run your file systems full. Even if you have a lot of allocation groups, having file system full on a per allocation group basis can create fragmentation. So when I take my file system, I try to allocate within an allocation group. If I carve it up into too many allocation groups, each allocation group ends up too small. So there is a frag command within XFSDB that can give me fragmentation statistics and also describe my free space. So here I just did a frag-D. Now I'm on a Barspool News file system, and notice my directories. In this case, I had almost 46,000 directories. Only 12,000 of them were contiguous. 73% of my directories were fragmented. But then when I looked at the files, I had 2,104,000 and 2,100,000 of them were ideal and not fragmented, so I got less than 0.2% fragmented. So it's just saying what percentage of my stuff is fragmented. Now, I would not be running this frag command very often or on a heavily loaded system. It does take time. And if you have a lot of metadata, it's going to suck up a lot of that metadata into buffers. XFSDB is doing this as raw I/O. And those buffers are going to create memory pressure as well. Mounts. So mount options. Mount-O we were already using for log devices, quotas. Here's the one I was talking about, in-memory log buffers, how big the blocks are when we write to disk, whether I want alignment turned on or off. Here again, on a web server, I might turn off access tracking. This is the one, Jeff, we were talking about, no dir A time. So that can turn off directory access tracking. That way, a find or an ls-r is not going to create a metadata storm and create a large journal. Well, actually, this is XFS, but still creating a large slab. And then here's the other one, AG skip. Now, I got to warn you, these last two are fairly new and do not show up in proc mounts yet. I filed a PV and there was code added in so that proc mounts would show these settings if they're set. Now, at USPS, for the example they were doing, he set the AG skip to even. And I would not do that unless my allocation group count was even. I'd like an odd number so that I get a skew through the allocation groups. If I got even groups and even skip, I'm going to end up back into the same allocation groups and never hit the odd ones. Does that make sense?
Yeah, I mean, it's vector stride all over again.
Right, exactly. So when I am using AG skip, I always pick an odd because allocation groups are always even. You don't want odd allocation groups because that could put an allocation group crossing spindle boundaries or crossing partition boundaries. So I always use even allocation groups. In fact, if I had 8 concatenate objects, I might actually make sure that my allocation group is a whole number multiple of the number of concats that I have, so that I do not have allocation groups crossing concats or, physical spindle boundaries. So I like my allocation groups if I set them to be a whole number multiple of the concats that I have in that file system, and I want an AG skip to get a skew, a stride, again, to make sure that I'm rotating through the allocation groups. You okay with that, Thomas?
Yep.
WSync is obviously going to say make the write synchronous. That's for reliability, but it's going to be negative performance impact. We can allocate and stripe width size more for the video market. Again, if I'm doing small files, that could result in wasted disk space. Let me just wrap up here. So mount options are documented there. XFS does have quota information. I would rather put quotas on a file system. If I have a RAID that's, say, 8+1, I'm not going to carve it into 3 partitions to isolate Army, Navy, Marines. If I take an 8+1 and carve it 3 ways, that's going to be bad and cause extra head movement. I'd rather put up disk quotas. That way, all 3 groups are basically allocated closer together, and I don't have head movement between multiple partitions. But a lot of people will take a drive and carve it up to protect one group from another. Part of the lab yesterday, assuming we get to it, is growing a file system. So after we attached with XVM, last time I looked, Jeff, you had built your first stripe, but did you ever grow it yet?
Yep.
Okay. So again, after I attach, I then go into grow FS, and we can actually see it grow here. And the trick there, Jeff, is inserting the concat to the right object. I have a lot of people that will insert it into the stripe they created rather than the stripe that pre-existed. You follow me?
Yeah, it would be just...
So in the lab, you've got 2 stripes. You've got the stripe that already exists, then you create a stripe, then you insert a concat. And I get a lot of students that will insert the concat into the stripe they just created, not the stripe that's part of the existing file system. Very common mistake. And if I don't use VE name, the lab exercise cannot guarantee the name of the stripe that you're trying to attach to. So anyways, after we're done, allocation group count looks like it also increased here. And it's an odd number. I don't like that myself. I'm not sure if it still does that. Size of an allocation group in 4 KB blocks. And we already talked about stripe width and stripe unit. There are some sysctl parameters. I have not played with any of these in a while. This one is of interest to me. H buffer centiseconds, XFS sync centiseconds. How often do we wake up? And also rotor step. And then there are some sysctl parameters that I don't think are relevant anymore for maximum. These are basically things that are read by SAR to get it out of the system. A little bit about creating a RAM disk and creating a shemem. Now, I need to warn you, TempFS has the ability to do a memory policy, but this may not be desirable. You need to look at your application. Again, if my asset fits on node, on socket, why would I want to interleave it across other sockets, particularly across the entire system? And it might make the allocation quicker, but if I'm post-processing it and reading it, the interleave might not be thread affinity aware. And now I've got high user time. And I was trying to warn you about this, Jeff. Allocation, if you shorten the allocation time, that's not a guarantee that the user time later is going to be shorter if it's not thread affinity aware.
Yeah, you get
and that's what I was warning about the calc.
Yeah, you get something like Fluent where it's multi-process in one section, but much more single-threaded in other sections. And
yes, typically they will zero it out, and it doesn't thread the same way, so the initialization is not the same way as the processing later. University of Minnesota was complaining about 40% degradation, and that's what it turned out to be. Now, we've been covering that even from origin days, and that dpro example that I showed you earlier in the week is proof of concept. So even in node info, when it says we're hitting on the allocation, that's not a guarantee that the thread that's going to use that is on that node. And we really need dplace to be thread memory range aware placement like we had in IRIX. That seems to be much more critical in UV. But when I mention that to Egan developers, they just scoff. I tell them, I'm probably way off base here, but blah, blah, blah. And they have other priorities. Huge TOBs I'm not covering this week. And then postmark, just what it's used for, what it's like. How long before your presentation there, or how long till you have to leave there, Thomas?
I gotta leave in about 5 minutes, I think.
Okay, let me flip through this.
I can always watch the video.
Well, I don't want to have a whole lot to say here, and I want to demo it tomorrow. So again, I kind of ran out of time, as I always do. Jeff knows what that's like, but page cache. Buffer cache, 2 parts. Buffer is for write traffic, buffered data, dirty data, delayed write data, or lazy writes. It goes from dirty, and then when it's marked for flushing, it's going to go to write back. And if we're going to NFS, it goes to NFS unstable. Again, we have a flush daemon that has a major minor number for each file system. Older releases, before SLES 11 SP1, we had a PD flush, and if it was busy for a second, it would spawn another PD flush, up to 12 of them. So if PD flush was in a block congestion, it would fire up to 12 PD flushes, and if they got idle, then they would go away. So you'd actually see PD flushes increase and decrease. Again, this whole flushing is for file coherency, not L1, L2 coherency. And XFS sync D is what flushes metadata to disk, but that's part of the slab, not part of the buffer cache. So we separated this out. Now, unfortunately, I'm going to have to do the profiling tomorrow. But using strace for the logical and block trace or sar-DP for the physical. I was calling this my fire bucket brigade. This is what I did. This is what I ran out of time for today, and I've got to do first thing tomorrow. Take a look at this more closely so we can ask questions. So this is just the coarse grain of that picture. Again, I also like to use the word impedance matching. I want to poke into what there were 12 different stages that I could poke into and see what's going on. I want logical, I don't want physical. I can get an upside down cache where my physicals are higher than my logicals. So clean or active, data read from disk or flush to disk is clean. Now, I, a long time ago, had them add cache underscore clean into PCP. It is derived. And this is important. Cache underscore clean from PCP is used, cached minus the dirty plus write back. I've got an RFE to add NFS unstable. But that is not clean, but still shows up in PCP's cache underscore clean. I'd also like to be able to subtract out and I should have said minus, not add, but also subtract out the shemem. Now, when I did this, I was trying to get to a gross view type of display. That was the whole thing I was trying to do. So if the clean data is not busy for a given amount of time, then it's put on the inactive list. Swappiness is what controls that. Basically, we go from active to inactive, which is called a page rotate, and we put it to the least recently used list. And node info does give me some of those statistics. So if short on memory, this is what we just saw. Everything was stuck on slab info even after I cleaned up everything else. And then inodes versus directory entries. And we were actually in the trimming trying to reclaim inodes. We pushed inodes down before directory entries. Now I'm leaving the question mark here because that depends upon the sysctl parameters. So when we run out of memory, we trim the slab first, then the inactive clean data, and then the active. And then we start swapping processes. And again, we now break out active and inactive. And don't forget about IPC, and that can be swapped to disk as well. So the flush daemon. Files are written by delayed flush daemon. Data is kept in memory depending upon settings. And we need to talk about dirty background ratio. Now, kernel memory is flushed asynchronously by default by flush. Sync will flush everything, and by the way, sync nowadays is synchronous. Some of us old-timers used to do sync, sync, sync before a shutdown. But nowadays, that was when sync was asynchronous. And metadata is flushed by XFS syncd, and there is a setting for how often that's going to wake up. We've already been through procmem info statistics. I'm not going to cover anything there. The tools, the SAR-B we've been through. Again, it's a total of disk stats. And we've already been through the memutil stuff. And again, there's my cache clean algorithm. Now here's what I want to get into tomorrow. And by the way, when I was doing trims today, this is what I wanted to look at for VM stats. And here's an example where I basically got all my memory dirty. This is actually SLES-9. In SLES-9, all my memory could go dirty. Nowadays, the maximum dirty is 50%. Unfortunately, it's not CPU set aware. So I could still fill up a lot of CPU sets with dirty memory and create problems for them. So this is the slide I wanted to get to, and then I'm done. I've got one more slide that's describing this. So dirty background ratio is the point at which we start flushing. Dirty ratio is the point at which we put the process to sleep and all my writes become synchronous. Dirty write back 7 seconds is how often I wake up. Dirty expire seconds is if I'm still below 10%, it will start flushing the data when it's 30 seconds old. BFS cache pressure we've talked about. If it's less than 100% or less than 100, we're going to protect the slab. If it's greater than 100%, we're going to protect the cache. And swappiness we've talked about is a default of 0. If it's 0, we're protecting anon. If it's 100, we're swapping anon and protecting the cache. And then zone reclaim mode, so that when I do a reclaim, I'm going to be NUMA aware. I haven't played with that much, but I remember Nate Perlstein had a PV where on a Lustre server it was switching its behavior and creating a problem. How often do I flush XFS data by age? How often do I wake up the flush daemon? And how often do I flush metadata? Every 30 seconds here. And then a min-slab ratio we've talked about. Now it's marked 10 here, but I've seen it drop down to 5 now. And these are the new ones now. Page cache limit MB, the largest the cache can be. And there is one to say ignore dirty within that. So when I run out of memory, this is what I wanted to do today, but didn't really work right. I actually see the slab get pushed down first, inodes, then directories, and we were seeing that. Then buffmem, then inactive, then active. And again, swappiness controls how quickly we go from active to inactive. Now, a big difference for both of you, when I closed the file, on IRIX the file was released from the cache. On Linux, it is kept in the cache after the close. Okay, and the file is only released when I delete the file or remove it. And again, if I remove the file inode, the data space is not freed up until the flush is complete. So here's kind of a drawing and then I'm done. I start up down here doing my writes. So this is kind of the PM chart stack display that we had. When I hit dirty background ratio, my disk flushing will start right there. Now I've upped my dirty background ratio to 49 just to create a problem. So when I hit dirty background ratio, my flush starts flushing, we start flagging write-backs. So right in here I start seeing write-backs. When I hit dirty ratio, which is 40% by default, but I've upped it to 50, which is the max, when I hit that dirty ratio, the process is put to sleep. Okay, and again, as I'm flushing, I'm going from dirty to write-back and then write-back to clean. There's a page cache limit. This is how big the clean can get. Again, it takes time to even trim a clean. Now, also in here, you can often see a step ladder. Let's see. Not a very good example. Here, you can see a step ladder. The flush daemon is waking up here and deciding what to flush, and it flushes. And then there's another wake up here, and then there's another wake up here. So you can often see a stair effect in here, and that is the wake up interval of the flush daemon. Once we get below 10%, the flushing stops until we hit dirty expire centiseconds. Now there is a really good page cache lab. I would encourage you to use this. Now what's wrong with 10% and 40% on a large memory machine? That's a lot of dirty data. 16 terabyte machine, I don't want to have 8 terabyte of dirty data before I start choking on it. So in general, I advise dropping these down to 5 and 10. Or even better now, they have them available by megabytes or by bytes instead of percentage. So here I can see my write starting. Here's the flush at 10%. Notice the flush stopped here, and then I had dirty data for a while. And then that expire centiseconds would result in a flush after 30 seconds. I'm done. You still with me, Thomas?
No, he left.
Okay. So I don't see any reason to go on at this point.
No, I mean you're at the end of your slides, right? More or less.
Did you catch when he left?
He left when you were on page 9-17.
Okay, that's fine then. Thanks for letting me know on that.
Sure.
So is there anything you want to do before we call the day?
No, I'll go do the labs. That'll be good.
Okay. So I kind of ran out of time, got squeezed today, but that's the way it goes. Hopefully the demos were constructive as well, but I'll see an email and we'll just pick up from here tomorrow and then go into CPU sets.
Sounds good.
Okay. I'll see you in an email.
Yep.